All right, let's look at our little practice test here. So we want to simplify each. For the first problem, we have x cubed multiplied by 2x cubed. So the idea here is we want to use what's known as the product rule for exponents. And again, if you have something like, let's say, a to the power of b multiplied by, let's say, a to the power of c, well, if you have the same base, in this case we have a and we have a, what you would do here is you would keep that base the same, so a stays the same, and you would add your exponent. So in this case, it would be to the power of b plus c, okay, like this. So that's basically what we have here. If we look at this, we have x cubed, and let me just write this out for clarity. This is x times x times x, and then we have multiplied by 2x cubed. So let me switch the order and just write this as x times x times x, and then I'll put the 2 at the end. We'll put it at the beginning in a moment, but I just want you to see that you have 1, 2, 3. So this is 3 factors of x, and then this is another 3 factors of x. So if I was to take it from this form and put it back into exponential form, basically I would have my 2 out in front, and then I would have my x, which would be the base. That's the, in this case, the variable that's being multiplied by itself. And I have 3 plus another 3, or 6 factors of x. So this would be 2x to the 6th power, okay? But again, you don't have to do this each time. You don't have to write things out as a repeated multiplication and then put it back into exponential form. All you really need to do to solve this problem is use that little rule. So again, we have our 2 here that's going to go out in front, and then we have x and x, so same base, okay? And then we're just going to add the exponents. So I have 3 and then 3, right? So I have 3 factors of x here, and then I have another 3 factors of x here. So basically, if those guys get multiplied together, then all you have to do is add 3 plus 3 to give you 6. So the answer here is 2x to the 6th power. Okay, for problem number 2, we're going to use the same rule. So we have x cubed times x squared. So again, same base, so x stays the same. Add the exponents, 3 plus 2 is 5. So this is x to the 5th power. Okay, let's look at problem number 3. So we have 3x squared times 2x squared. And in this case, you just have some coefficients that you need to multiply. So to show this, let me just reorder the multiplication. This is, again, using the commutative property. So let's go 3 times 2. I'm just going to put the numbers next to each other. And then times x squared again. And again, all I'm doing is 3 times 2, that's 6. And then x squared times x squared. Again, if I have 2 factors of this and another 2 factors of this, I have a total of 4 factors, right? So x stays the same, and you add the exponents. 2 plus 2 is going to give me 4. So this is 6x to the 4th power. Okay, let's look at problem number 4. So we have the negative of x to the 5th power, y to the 4th power, times we have the negative of x squared, y squared, and then times, inside the parentheses here, we have x squared, y squared, and this is raised to the 5th power. So I'm going to start by working on this part here, okay? And you need to know about another rule. Basically, if we're raising a power to another power, we want to keep the base the same, and we want to multiply exponents, okay? So let me break this down a little bit. First off, if I have something like, let's just say, well, let me not use x, let me use a and b. So let's say I have a times b, and this is inside of parentheses, and let's just say this is raised to the power of 3, just to keep it simple, okay? So it's cubed. Well, I'm going to raise each factor here, both a and b, to this number. So a gets raised to the 3rd power, and b gets raised to the 3rd power, okay? Now, to make this a little bit more interesting, let's say that a was already squared, and b was already raised to the 4th power. Here's where your power to power rule really kicks in, because a is already squared, okay, and b is already raised to the 4th power. So it's really like you have 3 of these guys, so a squared times b to the 4th power, then times a squared times b to the 4th power, then times a squared times b to the 4th power. Well, at the end of the day, what do I really have here? I have the same base of a, and a, okay? So if I'm multiplying, really all I'd have to do is add 2 plus 2 plus 2. So 2 plus 2 plus 2 is 6. But I could have gotten that by saying that I have 1, 2, 3 of these guys. So 2 times 3 would also give me 6. So that's the idea behind this. We'd keep the base a the same, and you'd multiply the exponents. 2 times 3 would give you 6. Same thing goes for b. You have b to the 4th power, b to the 4th power, b to the 4th power. Well, basically, this is 4 plus 4 plus 4, which is 12. Or I could do 4 times 3 and get 12 as well. Okay, so that's our rule for this guy. So to apply it here, I'm going to have x squared raised to the 5th power. So x stays the same, and we multiply exponents. 2 times 5 is 10. And then for y squared raised to the 5th power, y stays the same, multiply exponents. 2 times 5 is 10. Okay, Then let me copy all this stuff down here. So I'm going to write this negative as -1. I think you want to do that when you first start working with exponents to make things crystal clear. So times x to the 5th power, y to the 4th power, times, I'm going to write this as -1. So times x squared, y squared, okay, then times this. Now, if I have -1 times -1, that's gone, right? That's +1. You can just cancel those. Get rid of them. That way it's gone. Now let me scroll down and get some room. So all we have here is just straight multiplication. So I have x that's going to stay the same, okay? And I'm just going to add the exponents on all the x's. So I'm going to have this 5, I have this 2, and I have this 10. So 5 plus 2 is 7, 7 plus 10 is 17. And then we have our y here. Again, what's my exponent? So 4, then I have 2, and then I have 10. So 4 plus 2 is 6, 6 plus 10 is 16. So our end result here is going to be x to the 17th power, y to the 16th power. All right, let's look at problem number 5. So inside of parentheses here, we have the negative of x being raised to the 5th power, and then times we have x to the 5th power y squared. So for this one, I'm going to start with this operation here. Notice how my negative and my x are wrapped in parentheses, but my exponent here is odd, okay? So it's just like I had -1 times x raised to the 5th power. This is really -1 to the 5th power times x to the 5th power. And if I raise -1 to the 5th power, well, it's still -1, right? Raising it to an odd power or raising it to an odd exponent, in this case it's 5, or if it was 3 or 9 or 11 or whatever it is, you're still going to get a negative there. So you can just put the negative out in front, or you can say it's just -1 times. So -1 times, I'll put x to the 5th power. I like to put -1 when I'm doing these examples just to make things crystal clear. So then times, you have x to the 5th power again, and then y squared. So the idea here, I'm just going to put a negative out in front, or you can put the -1 if it's more comfortable for you. Then x stays the same. You have an exponent of 5 and an exponent of 5. You're going to add the exponents. 5 plus 5 is 10. Then you have y squared. So really, this is the negative of x to the 10th power, y squared. Or if you want to put -1 times x to the 10th power, y squared, it's really up to you. Okay, let's look at problem number 6. So inside of parentheses, we're going to have the negative of x squared y cubed times the negative of x squared y to the 4th times the negative of x cubed. And this is all being squared. So what I want to do is I want to treat these negatives, again, as -1. So if I had, let me write this out for clarity. So if I had -1 times -1 times -1, I'm just reordering my multiplication, which is legal, and then times x squared. Let me put the x's next to each other. So times x squared, and then times x cubed, and then times you have y to the 3rd power, or y cubed, and then times y to the 4th power, and this is all squared, okay? So I can see clearly that this right here is going to be -1. You have 3 factors of -1. It's an odd number of negative factors, so it's negative. So this right here would be -1, you can put, and then times, you have x stays the same, 2 plus 2 plus 3. So 2 plus 2 is 4, plus 3 is 7, okay? And then times, you have your y stays the same. You have 3 plus 4, which is also 7. And then this is raised to the 2nd power, okay? So now, let's think about this. This guy right here is within these parentheses here, okay? And it's raised to the 2nd power. So that means both the negative and the 1 will be raised to that 2nd power. So in the end, this is going to be positive. But let me show this for clarity. I'm going to write this because this 2 is going to be applied to each factor in here. So I'll have -1 squared times, I'll have x to the 7th power being squared, and then times I'll have y to the 7th power. Let me make that better. So y to the 7th power being squared. So -1 being squared, we know that's -1 times -1. Again, there's parentheses around the base there, so that's 1. Then x to the 7th power being squared, keep x the same, multiply the exponents. 7 times 2 is 14. Then times, you have y to the 7th power being squared, y stays the same, multiply the exponents, 7 times 2 is 14. So your result here is x to the 14th power, y to the 14th power. Okay, let's look at problem number 7. So here we have the negative of x to the 4th power raised to the 5th power, and then times the negative of xy. So this one's actually a little bit tricky to make sure that the sign is correct. This is really going to stop a lot of people from getting the right answer. So this is wrapped inside of parentheses, but I want you to notice that this exponent here is going to be odd, okay? So it's just like if I said that I had -1 raised to the 5th power times x to the 4th power raised to the 5th power. So this -1 to the 5th power is going to be an odd number of negative factors. So that's -1, or you can just put negative out in front, whatever you want. Let's just put -1. And then this guy, x to the 4th power raised to the 5th power, is going to be x to the power of 4 times 5, or 20. Okay, so this, I want to make sure that's crystal clear. This is different from if we had, let's say we had the scenario where I had something like, let's say negative of x, so that's enclosed in parentheses, raised to the fourth power, and let's say now this is all raised to the fifth power. Well, the negative and the x are raised to an even power now, so this would basically be negative 1 to the fourth power, which is 1, and then multiplied by x to the fourth power, which is x to the fourth power. So this would be x to the fourth power raised to the fifth power. Let me show that. And this would end up being x to the power of 20, right? 4 times 5 is 20. So that's the difference in sign in terms of the notation. Here, the negative is wrapped inside of parentheses while it's being raised to the fourth power. Here it isn't, right? We have the negative of x to the fourth power. Here we have negative x wrapped in parentheses raised to the fourth power. So I know this seems kind of trivial for most of you, but there's a lot of people who really struggle with this concept. So I want to make sure it's crystal clear. Okay, let's get rid of this. So times, I'm going to write this negative as negative 1 and then xy. So negative times negative is going to be positive, right? So negative 1 times negative 1 is positive 1. So really you can just cancel it if you want to show it that way. Let's just mark it out so it's gone. You have x to the power of 20 times x. Again, you could put a visible exponent of 1 there if it helps you. This is going to be x to the power of 20 plus 1, which is 21. And then just times y, right? So just times y. If you want to put y to the first power, you can, but really it's unnecessary. So x to the 21st power times y. All right, so for problem number 8, hopefully you didn't spend too much time on this. This is a trick question because everything is just raised to the power of 0. So any non-zero number or any non-zero expression raised to the power of 0 is going to be 1. We would assume for a problem like this that we have a non-zero expression. And so the answer would just be 1. All right, let's look at problem number 9. So this one is a little bit tricky. So inside the parentheses, we have the negative of xy to the fourth power times we have inside of parentheses here, the negative of x squared being squared, then over z squared times q cubed raised to the power of 0. And this whole thing is squared, right? So everything inside the parentheses is squared. Okay, so I'm going to start inside. And obviously this right here, this q cubed being raised to the power of 0, that's going to give you 1, right? So let me just write this out. I'm going to put the negative of xy to the fourth power. And then down here, I'm going to have my z squared. Forget about, you can put times 1 if you want, but you can really just leave it off and put z squared down here. Up here in the numerator, this is where a lot of people are going to get tripped up. You have the negative of x squared here, but this is being squared, okay? So because this negative here is wrapped in these parentheses here, it's being squared, really, you could write this as negative 1 times x squared, okay, being squared. And what this is the negative 1 is being raised to the second power. So I'm going to really write this as negative 1 like this, both the negative and the 1 wrapped, being squared, times you have your x squared squared, okay? So let me wrap this all in parentheses and square it. Let me come down here a little bit. So x squared squared is x to the fourth power. Let me just edit this right here, put x to the fourth power. We know that negative 1, again, with parentheses around the base, being squared is positive 1. So you can really just get rid of that, okay? And so the other thing I want to do is take this x here. I'm going to write this as negative 1 times that. X times x to the fourth power is x to the fifth power. So let me get rid of this and write x to the fifth power here, okay? And now really all I have left to do is apply this exponent here. And I'm just going to use the power to power rule to do that. So negative 1 squared, again, this is wrapped in parentheses here, okay? So negative 1 being squared is going to look like that. And then we have y to the fourth power being squared. And then we have x to the fifth power being squared. And this is over z squared being squared. Okay, and let me make that 2 a little bit better there. Okay, so let's calm down. So what is negative 1 being squared? Well, again, this is wrapped inside of parentheses, so that's positive 1, right? So if you want, you can just cross that out. That's going to be positive 1. Y to the fourth power being squared, well, y stays the same. 4 times 2 is going to give you 8. Then x to the fifth power being squared, x stays the same. And then we're going to multiply 5 times 2, that's going to give us 10. And then in the denominator, we'd have z staying the same. And then we'd multiply the exponents, 2 times 2 is 4. So we end up with x to the 10th power, y to the 8th power over z to the 4th power. All right, for problem number 10, we have a lot going on. So inside the parentheses, we have 2x squared times negative 2y to the 8th power, and this is squared. Multiplied by, inside the parentheses, we have 2x to the 5th power times y cubed, and this is cubed. And then over, inside the parentheses here, we have z squared, q to the power of 0, w cubed, and this is all cubed. Okay, so let me start up here inside the parentheses. First off, is there anything I can do to simplify? Well, 2 times negative 2 is negative 4. Let me go ahead and write this as negative 1 times 4, okay? And then I have x squared, and then I have y to the 8th power. Now this is all squared. So again, if I apply this exponent to everything, the negative 1, again, is wrapped inside the parentheses there. So negative 1, both the negative and the 1 will be squared. So what I would do is I would say that this is negative 1 being squared, and then you have 4 that's being squared, and then x squared is being squared. Let me put some multiplication symbols in there. And then y to the 8th power is being squared. Okay, let me erase this from up here. So negative 1 being squared, we know that this is going to end up being positive 1. 4 squared is going to be 16. Okay, we can write that as 16. X squared squared is going to be x to the power of 2 times 2 or 4. And then y to the 8th power squared is going to be y to the power of 8 times 2 or 16. Okay, so that part is done. Then when we look at this part right here, really I would just apply this exponent. So you would have 2 that's being cubed, okay? And then we have x to the 5th power being cubed, so x stays the same, 5 times 3 is 15. And then y cubed is cubed, y stays the same, 3 times 3 is 9, okay? So before we even get into the denominator, let's think about how we can simplify. 16 is 2 to the 4th power, so let me write that like that. So we have 2 to the 4th power times 2 cubed. Keep the base 2 the same and add the exponents. So this would be 4 plus 3 or 7. So this is 2 to the 7th power. Then here, x to the 4th power times x to the 15th power. Well, basically x would stay the same. 4 plus 15 is 19. Then lastly, we have y to the 16th power times y to the 9th power. Y stays the same, and then 16 plus 9 is 25. Okay, so this is over. Down here, I'm going to apply this exponent to everything. So z squared raised to the 3rd power, z squared cubed, z stays the same. And then 2 times 3 is 6. So this is a z. I want to make sure that's clear because a lot of people say my z's look like 2's. So let me make that crystal clear. So then this guy, q to the power of 0, we know that's 1, so don't even write it. Then we have w raised to the power of 3 times 3, which is 9. So our answer here would be 2 to the 7th power, or 128 if we want to write it that way. Then x to the 19th power, y to the 25th power, over z to the 6th power, w to the 9th power. All right, let's take a look at our little practice test. So we want to determine if each pair of terms are what we call like terms. So remember, when we think about like terms, we would say that these are terms that contain the same variable, or it could be variables if you have multiple, where they're each raised to the same power. The coefficients can be different, but if you have the same variable, you have to also check to make sure it's raised to the same power. So identical parts when you think about the variable or variables involved. Let's look at the first problem. So we're given 3x and then we're given 7xy. Okay. So again, don't worry about the coefficients. So don't worry about the 3 or the 7. It's not important for this. You want to make sure that each term has the same variable or variables. This one has an x, and this guy has an x, so far so good. But then this guy right here is going to have a y, whereas this guy does not have a y. So these guys are not like terms because this guy right here does not contain the same variables as this guy, right? This has only an x, and this guy has an x and a y, right? So they're not the same. So these would be not like terms, okay? Now, if this was 3xy and 7xy, then those would be like terms because in each case I have x to the first power, so x to the first power and x to the first power, and then also y to the first power and y to the first power. So you can see that the variables there are exactly the same. For problem number 2, we have 2x squared y, and then we have negative 9yx squared. So again, I'm looking at the variables. So here it's x squared and x squared. And then here it's y and it's y. So it's exactly the same. It doesn't matter that the order is switched here. I have x squared y, here I have yx squared. That's completely irrelevant because when you multiply, you can do that in any order. So I could really write this term as negative 9x squared y, okay, and it's the exact same thing. It doesn't matter. So these are going to be like terms. These are like terms. Okay, let's look at problem number 3. We have negative 14x to the 4th power, y squared z, and then we have 7x squared, y to the 4th power, z. So if I look at these guys, again, I'm looking at the variables involved. So you'll notice that you have an x, a y, a z, and a z. So we have the same variables, but we also need to make sure that they're raised to the same power. In other words, here I have x raised to the fourth power. Well, for me to have like terms, I would need to have x raised to the fourth power here, and clearly I don't. This is x squared, okay? If you continue, although it's already failed, if you continue, here you have y squared, here you have y to the fourth power, so that's different as well. Here you have z to the first power and z to the first power, so that one's okay. But again, if only one of them fails, the whole thing fails, and you don't have like terms. So these are not like terms. All right, for the next few problems, we want to determine if the following algebraic expression represents a polynomial. Remember, a polynomial is either a single term or it's a finite sum of terms where basically the exponents that are going to be allowed on the variables, they're all going to be whole numbers. So 0, 1, 2, 3, something like that. You can't have something like a half or a -2 or a -4, something like that. Now, we haven't gone too far into exponents in this course yet. We've only covered things like the product rule for exponents and the power rules. But I will tell you later on, we're going to get to stuff like, let's say we have the square root of x. This can be written as x to the power of a half, okay? So if you saw this in an expression and they said, hey, is this a polynomial? This is a no-go because this right here is not a whole number, okay? Then also something like 1 over x, if you get that, that can be written as x to the power of -1. Okay, so this is a no-go because this guy is not a whole number either, right? It's an integer, but it's not a whole number. So in this particular case, let's just start off with problem number 4. We have 1/3 x squared minus 3/5 x plus 3. No problems with your exponents here. This is 2 and this is 1. So we're good to go. You can just answer yes, this is a polynomial. Then for number 5, we have 9x cubed minus the square root of x, then plus 13. Again, you can write this as x to the power of a half. And basically you can see that this would not be a whole number exponent. So this would be no. This would be no. Then for problem number 6, we have 2/3 x squared minus x plus 5 over x. Again, you could write that as 5 times x to the power of -1. So this part right here, because it's not a whole number, makes this fail. So this is a no as well, not a polynomial. Now we want to write each polynomial in standard form. In order to do this, if you have just one variable involved, you're basically going to look for the highest exponential power on your variable, okay? And then that term is going to go all the way to the left, or it's going to go first. Then you're going to look for the next highest. That's going to go second. Then the next highest. That's going to go third, so on and so forth. So if I look at this problem here, number 7, I have 9x cubed minus 7x to the fourth plus 4x squared minus x plus 8. Okay, what's the highest exponential power? It's going to be this 4. Then it would be the 3. Let me label this. So this is the first, or the highest. This is the second, okay? Then this is the third. And then this guy right here is the fourth, right? Because you can basically say this is x to the first power. And a lot of books will show this. They'll say this is 8x to the power of 0. Because again, when you raise a non-zero number to the power of 0, you get 1. So really this is just like saying 8 times 1, which is 8. So this would be fifth right here, okay? So if I wanted to rewrite this, let's just go ahead and say in standard form, you would have your negative 7x to the fourth power. Don't forget to bring that negative with you, okay? And then basically I would have plus my 9x cubed. And then plus, I'd have my 4x squared, and then minus, I'd have my x, and then plus, I'd have my 8. Okay, you don't need to write the x to the power of 0. That was just for emphasis there, okay? So this would be your standard form. Let me make that 3 a little bit better. And again, you just notice how this is the highest exponent, the next highest, the next highest. And again, if you wanted to write this as, let's say, a 1 here, and then x to the power of 0 here, I'll delete it in a second. This would be the next highest, and then the next highest, right? So you have the smallest here all the way to the right. And again, you can delete this just for clarity. So we get negative 7x to the fourth power plus 9x cubed plus 4x squared minus x and then plus 8. Okay, let's look at another one. So basically we have 12xy minus 4x squared y minus x plus 5x cubed y squared minus 1. So when you have two variables involved, first off, I'm going to say that most textbooks don't even cover this situation, okay? And a lot of times you get disagreement in terms of what you need to do. Okay, but this is what I have come to understand. Basically, you're going to first start by looking at what is the highest degree. Okay, to find the highest degree of a term, then basically what you want to do is you want to add all the exponents on the terms. Okay, so in other words, here, this would be a 1 and this would be a 1, so the degree is 2. Okay, this would be a 2 and this would be a 1, so the degree is 3. This is a 1, the degree is 1. This is a 3 and a 2, so the degree is 5. And then this guy you could say, again, is x to the power of 0, so the degree is 0. Okay, so for this one, it's fairly straightforward. I would just take the term with the highest degree and I would list it first. So I would say this is 5x cubed y squared. And then next, I would go to minus 4x squared y. And then next, I would go to plus 12xy, and then I would go to minus x, and then I would go to minus 1. So now what we want to do is find the degree of each polynomial. So the degree is going to be the highest degree of any term. Okay, that's all you need to do. And again, for finding the degree of a term, you just add the exponents. That's all you do. So for problem 9, you have 19x to the 5th power y squared minus 12x to the 8th power y plus 13xy minus 5. So the degree here is 7, 5 plus 2. The degree here is 9, 8 plus 1. The degree here is 2, 1 plus 1. And the degree here, again, if you have just a constant, a number by itself, you could always say this is 5x to the power of 0. But again, you don't have to keep doing that. The degree there is just going to be 0. Okay, so what's the highest degree? This one's 7, this one's 9, this one's 2, this one's 0. So obviously it's 9. So the degree of the polynomial is 9. Okay, for number 10, we have 20x squared y squared z squared minus 15x to the 9th power plus 7y to the 5th power z cubed. Okay, so again, just count the exponents. 2 plus 2 plus 2 is 6. And then this guy is just 9. This guy is 5 plus 3, which is 8. So obviously the 9 is the highest exponential power. So that's the degree of the polynomial. So your degree here is going to be 9. All right, let's take a look at our little practice test. So we want to simplify each. And for the first problem, we have this quantity 2x to the 4th power minus 5. And then we are subtracting away. We have this quantity 5 plus 5x to the 4th power. So when you add polynomials, basically all you need to do is drop your parentheses and then just combine like terms. When you subtract one polynomial away from another, you have an additional step. So what you want to do is change your subtraction operation into addition of the opposite. So a lot of people put a plus sign there and they'll put a little negative 1 here to remind themselves that they want to distribute this negative 1 to each term inside of the parentheses, and that's going to change the sign of each term. Okay, so what we're going to do is we're going to leave this leftmost polynomial unchanged. So this is the 2x to the 4th power minus 5. And then this guy right here, instead of 5, I'm changing the sign. So this will be minus 5. And then this guy, this 5x to the 4th power, again, I'm multiplying it by negative 1, so I'm changing the sign. So this is minus 5x to the 4th power. Okay, so at this point, you could just go through and perform your operations. It's typically best when you first start doing this to write your like terms next to each other. So you'll notice that you have this x to the 4th power, you have this x to the 4th power. So let's put those two terms next to each other. I'm going to put the 2x to the 4th power, and then you can go minus, or you can do plus negative, whatever you want to do, this 5x to the 4th power, and then the minus 5, and then the minus 5, okay? So how do we combine these? Remember, if you're combining like terms, the variable part is going to stay unchanged. It's just like if I did this. So if I had 2x to the 4th power minus 5x to the 4th power, and I factored out what was common. So if I factored this out, that would go in front of a set of parentheses. And then inside what's left? Well, I have this 2, and then I have this minus, and I have this 5, okay? So 2 minus 5 would be negative 3. So this would give me negative 3 times x to the 4th power, okay? So we're really just using the distributive property there. And so let's do this here. Again, this x to the 4th power part just stays unchanged. Don't mess with that. I say it comes along for the ride. You just do 2. So you're going to do 2 minus your 5. So just work with the coefficients. That's going to be negative 3. And then the x to the 4th power comes along for the ride. Then here we basically have negative 5 minus 5, which is just negative 10. Okay, so our answer here would be negative 3x to the 4th power minus 10. Okay, let's look at an addition problem now. So for problem 2, we have our quantity x cubed minus 3x, and then plus we have our quantity 3x plus x cubed. So for an addition problem, just drop your parentheses and combine like terms. So I'm just going to go x cubed, and then I'll just take this x cubed from over here. I'm just going to write them next to each other. And then I have minus 3x and then plus 3x. Well, basically, again, if you have like terms, like you have here, and then of course you'll have there and there. Let me switch the highlighted color for that. So then here and here. What you want to do is just add the coefficients, okay? And then you want to keep the variable part, in this case it would be x cubed, in this case it would be x, unchanged, okay? So if I think about x cubed by itself, there's no visible coefficient. So when this happens, the coefficient is understood to be 1. So let's write that in for clarity. So 1 plus 1 would be 2, okay? And then the x cubed just comes along for the ride. Here I have negative 3x plus 3x. Well, basically these guys are opposites, right? Negative 3 and 3 are opposites. We have opposite coefficients. So this is just going to cancel and become 0. You can line it out or you can put plus 0, whatever you want to do. But at the end of the day, it's gone. So you just have 2x cubed. Okay, let's look at another one. So for problem 3, we have the quantity 5x squared minus 5x to the 4th power. Then plus we have the quantity 3x to the 4th power plus 3x squared. So again, I'm just going to drop my parentheses. And let me write my like terms next to each other. So I'm going to put negative 5x to the 4th power, so this term here, plus my 3x to the 4th power, so this term here. And then let me go plus 5x squared, and then plus 3x squared. So again, we're just going to combine like terms. So this guy and this guy, those are like terms. And again, I'm just looking at the coefficient. So what's the coefficient here? Negative 5. What's the coefficient here? It's 3. Negative 5 plus 3 is negative 2. So negative 2, and then the x to the 4th power just comes along for the ride. So now I'm looking at these like terms. Let me highlight this. So these like terms here. Again, x squared is just going to come along for the ride. So go ahead and just write that in. Combine the coefficients. So 5 plus 3 is 8. So this is 8x squared. So in the end, our answer here, let me make this plus sign a little bit clearer, is negative 2x to the 4th power plus 8x squared. Okay, let's look at a mixed problem. So for problem number 4, we have the quantity 5x to the 4th power minus 3x cubed. Plus, we have the quantity 4 plus x cubed, and then minus, we have the quantity 7x cubed minus 5x to the 4th power. So, when you're subtracting away a polynomial, remember, you're going to change it into addition of the opposite. So I'm going to make this a plus, and I'm going to put a negative 1 here, and then I'm going to show that I'm going to distribute the negative 1 to each term inside of the parentheses. So for these guys over here, I'm just going to drop the parentheses. So 5x to the 4th power minus 3x cubed, and then plus, you'll have, and I'll just change the order, so x cubed plus 4. And then for this guy, remember, we're changing the sign of each term. So I'm going to put, this would be minus 7x cubed, right? So I'm changing it from 7x cubed to minus 7x cubed, or plus negative 7x cubed, however you want to write it. And then instead of negative 5x to the 4th power, this is going to change to positive 5x to the 4th power. So again, if you're subtracting away a polynomial, you're adding the opposite. So change the sign of each term inside of the parentheses. That's all you need to do. So let me look for what we have here. We've got 5x to the 4th power and 5x to the 4th power. So basically 5 plus 5, if you add those coefficients, that's going to be 10. And then x to the 4th power comes along for the ride. Let me erase that. And I didn't mean to do that. So let's just erase this. And then the next highest, we have this negative 3x cubed and negative 7x cubed, and then x cubed. Okay, so we want to think about the negative 3. This is an implied coefficient of 1, so negative 3 plus 1 is negative 2, and then negative 2 plus negative 7 is going to be negative 9. So let me put minus 9x cubed, like this. And then lastly, you just have this 4 here, nothing to combine with that, so just plus 4. So our answer here is 10x to the 4th power minus 9x cubed plus 4. All right, let's look at problem number 5 now. So we have this quantity 7x cubed minus 6x to the 4th power, then plus our quantity 5x to the 4th power minus x cubed. Lastly, minus this quantity 6x to the 4th power plus 2x cubed. Okay, let me put equals here. And of course, for this guy and this guy, you can just drop the parentheses because it's just this addition right here. But once again, when you see subtraction, you want to change this into addition of the opposite. So plus, put my little negative 1 there, and then I'm going to distribute that to each term inside of the parentheses. So again, for these first two, I'm just going to drop the parentheses. So 7x cubed, and then minus 6x to the 4th power. Let me make this a little bit better. So let me draw that a little bit better. And then plus, I'll have my 5x to the 4th power minus x cubed. So here's where we have to do a little bit of work. We need to change the sign of each term inside the parentheses. So instead of plus 6x to the 4th power, it'll be minus 6x to the 4th power. Instead of plus 2x cubed, it'll be minus 2x cubed. So that's all we're doing by multiplying something by negative 1. You're just changing the sign, okay? So let's put equals here, and let's think about our answer. So in terms of like terms, I want to think about the highest exponential power I'm going to see first, and that's going to be an exponent of 4. So I'm going to have this here with 5x to the 4th power, here with negative 6x to the 4th power, and here with negative 6x to the 4th power. So for my coefficients, I have negative 6 plus 5, that's negative 1, and then plus negative 6, which is going to be negative 7. So I'll have my negative 7, then the x to the 4th power comes along for the ride. Let me erase this little highlighting here, and I didn't mean to erase this 4 here, so let me put that back in. And then let me highlight the other ones. So 7x cubed now, negative x cubed, and negative 2x cubed. So those are going to be my other like terms in this problem. And of course, if you just see negative right, in front of a variable like negative x or negative y, in this case it's negative x cubed, the coefficient there is implied to be negative 1. So you can put negative 1 there like that. It's just for clarification, okay? So let me highlight this. And so basically what I do, if I look at the coefficients, I have 7 minus 1, which is 6, and then 6 minus 2 would be 4. So this would be plus 4. And then my x cubed comes along for the ride. So my answer here is negative 7x to the 4th power plus 4x cubed. All right, let's look at problem number 6. So we have this quantity 3x squared plus 8x to the 4th power plus 8 minus this quantity 7 minus x squared plus 8x to the 4th power, and then plus this quantity 5x squared minus x to the 4th power minus 1. Okay, so let's come down here. And for the first polynomial, I can just leave it. So I'm going to have my 3x squared plus 8x to the 4th power. Let me make that 8 a little bit better. And then plus 8. I don't need to really do anything other than drop the parentheses. For this next guy, again, it's being subtracted away. So I'm going to put a plus here. And let me make that a little bit better. So let me just put a plus there like this. And then I'll put a negative 1 here. And I'm going to distribute this to each term inside of the parentheses. So instead of 7, I'll have negative 7. So I'll put minus 7. Instead of negative x squared, I'll have plus x squared. And instead of plus 8x to the 4th power, I'll have minus 8x to the 4th power. So again, you're just changing this to addition of the opposite. That's all you're doing. Okay, and then for this guy, since it's just addition here, I'm just going to drop the parentheses. So I'll put plus 5x squared minus x to the 4th power and then minus 1. Okay, let's scroll down and get some room going. And what do we have for like terms here? So we have 8x to the 4th power. We have minus 8x to the 4th power, so those are going to go away. And then basically minus x to the 4th power, right? So for those guys, again, 8x to the 4th power minus 8x to the 4th power, well, 8 minus 8 is 0, so those are going to cancel, right? So basically I'm just left with this negative x to the 4th power, and probably I want to write this down here. So let me write this down here as negative x to the 4th power like this, make that a little bit better. And then let me erase this highlighting here. And then what are we looking at next in terms of like terms? I don't have any x cubed, so I would go to x squared. So I have that here, and I have that here, and then I have that here, right? So basically I would have 3 plus, again, this is an implied coefficient of 1. So 3 plus 1 is 4, and then plus 5 is going to be 9. So let's put plus 9x squared. Let's undo this highlighting once again. And I did not mean to do that, so let me write that as x again. So then what else do I have? I have this 8, I have this negative 7, and then I have this negative 1, right? So let's combine those. So basically 8 minus 7 is positive 1, and then positive 1 minus 1 is 0. So again, you could put plus 0, but it's really unnecessary. Your answer here is negative x to the 4th power plus 9x squared. All right, let's look at the next problem. So for problem number 7, we have the quantity 4x squared minus 5x minus 6, and then plus the quantity 6x squared minus 6x plus 3, and then minus the quantity 4 plus 6x squared minus 3x. Okay, so let's scroll down just a little bit here. Again, for this one and this one, because there's addition, you can just drop the parentheses. You don't need to do anything fancy. So this is 4x squared minus 5x minus 6, then plus, I'm going to have 6x squared, then minus 6x, and then plus 3. Okay, so for this guy right here, we have a minus out in front. So if we're subtracting away a polynomial, we know at this point that we put plus, put a negative 1 there, and I'm just going to distribute this to each term inside of the parentheses. So I'll have negative 4, and then I'll have negative 6x squared, and then I'll have positive 3x. So just change the sign of everything. Instead of positive 4, I have negative 4. Instead of positive 6x squared, I have negative 6x squared. And instead of negative 3x, I have positive 3x. So that's all we're looking to do. Let me put equals here. Let me scroll down and get a little bit of room going. And then for like terms, I have 4x squared, I have 6x squared, and then I have negative 6x squared. So obviously 6x squared and negative 6x squared, those are going to cancel. So I'll just have my 4x squared there. Let me change the colors up a little bit. So let me use this blue or teal or whatever this color is. So just 4x squared. And then let me erase this and this and this. And then the next guy we're looking at is x to the first power. So we have negative 5x, we have negative 6x, and we have 3x. Okay, so let's go ahead and take a look at negative 5x minus 6x is negative 11x, and then negative 11x plus 3x is going to be minus 8x. Okay, so let me erase this and this and this. And then the next guy we're going to look at, we have this negative 6, we have plus 3, and then we have minus 4. okay? So if I do negative 6 plus 3, that's negative 3, and then negative 3 minus 4 would be minus 7. So my final answer here would be 4x squared, and then minus 8x, and then minus 7. All right, so look at problem number 8. So we have the quantity 6x squared minus 6y to the 4th power, minus our quantity 7y to the 4th power minus 4x squared, and then plus we have this quantity 4y to the 4th power plus 6x squared. All right, so let's scroll down and get some room going here. And for the first guy, I'm just going to drop the parentheses. So 6x squared minus 6y to the 4th power. Then I'm going to put plus and then negative 1 here and distribute this to each term. Okay, because again, if you're subtracting away a polynomial, you're going to add the opposite. So instead of 7y to the 4th power, I'll have minus 7y to the 4th power. And then instead of minus or negative 4x squared, I'll have plus 4x squared. Okay, then this is plus here, so I don't need to do anything with this. So I'm just going to drop my parentheses. So I'll have 4y to the 4th power plus 6x squared. Okay, so from here, I'm good to go. And basically, I'm just looking for like terms. So I'm going to go ahead and go with the y to the 4th power first, because the degree of that term would be higher, right? It has a higher exponential power. So if I want to write this in standard form and I have two variables, you're going to look at what has the highest degree. So let's look at this guy right here and this guy right here. Okay, so you're going to have negative 6 and negative 7. So negative 6 minus 7 is going to be negative 13. And then you're going to have plus 4, which is going to be negative 9. So let's put negative 9 y to the 4th power. And then let me erase this highlighting here. And now what we're going to do is go to the x squared. So we're going to have 6x squared, we're going to have 4x squared, and we're going to have 6x squared. Okay, so if we look at this guy, we'll have 6 plus 4, which is 10, then plus 6, which is 16. So this is plus 16x squared. So the answer here would be negative 9y to the 4th power plus 16x squared. All right, let's look at problem number 9. So we have the quantity 7x squared minus 6x cubed, then plus we have the quantity y minus 7x squared, then plus we have the quantity 4y plus 2x squared. Okay, let's scroll down and get some room going here. And basically what I want to do is just drop the parentheses in each case because I have plus and I have plus. So let's put equals. We'll have 7x squared and then minus 6x cubed. And then plus we'll have 7 minus 7x squared. And then plus we'll have 4y plus 2x squared. Let me scooch this down so it fits on the screen properly. Okay, let's put equals. And again, I'm just looking to combine like terms. So I'm going to look and see that I have a negative 6x cubed there. I don't have anything to combine with that. So let me go ahead and write that first. So negative 6x cubed. And then let's look at x squared. So we have 7x squared, we have negative 7x squared, and then we have 2x squared. Okay, well 7x squared minus 7x squared is 0, right? That's going to cancel because 7 minus 7 is 0. And then you're just left with that 2x squared. So plus 2x squared. All right, so the next guy we're going to look at is going to be our y. So we have this guy right here and then the 4y right there. And again, if you just see a y or an x by itself, it has an implied coefficient of 1. So basically you have 1 plus 4, which is 5. So I'm going to put plus 5y. So the reason I wrote it in this manner, again, if you have two variables, generally for standard form, what you want to do is you want to write this in terms of the highest degree first, right, that term. So this variable here, x, is cubed. So the degree of this term is 3, this one is 2, and this one is 1. So that's why I wrote it in that manner. Again, the standard form when you have two variables, it's really up to your teacher. Okay, for problem number 10, we have this quantity y plus 2xy plus 5x to the 4th power y to the 4th power minus this quantity 6x to the 4th power y to the 4th power plus 6xy minus x to the 4th power y cubed, and then minus this quantity 6x to the 4th power y to the 4th power minus 8x to the 4th power y cubed. Okay, so we see we have minus and we have minus. So I'm going to change this to plus a negative 1. And I know this is going to go off the screen, but this is going to get multiplied by each term here. So you distribute it to each term inside the parentheses, and I'll put plus negative 1 here. I'm going to do the same thing there, okay? So the first guy here, I'm just going to drop the parentheses. So you'll have y plus 2xy, and then plus 5x to the 4th power, y to the 4th power. Then for this guy, I'm changing the sign of each term. So this will be, and let me change the color here. So minus 6x to the 4th power, y to the 4th power. I'm just changing the sign. Minus 6xy, just changing the sign. And this will go from negative to positive, so plus x to the 4th power y cubed. Okay, so all I did was I changed the sign of this, this, and this. That's what distributing the negative 1 does. Let me scroll down and get some room going. I think we're going to run off the screen here. So although you can't see it up there, actually I can scroll up to make you see it. So this guy, again, this negative 1 is going to multiply by each guy inside. So the negative 1 times 6x to the 4th power y to the 4th power would be minus 6x to the 4th power y to the 4th power. And then the negative 1 times the negative 8x to the 4th power y cubed would be plus, right? I'm just changing the sign, 8x to the 4th power y cubed. All right, so in terms of how I'm going to write this in standard form, I'm going to look for the term at the highest degree. So it looks like any term with x to the 4th power, y to the 4th power, the degree is 8. So let's take this one, and this one, and this one. Let's combine those first. So if you basically have 5 plus negative 6, that's going to be negative 1. And then negative 1 plus negative 6 is going to be negative 7. So this would be negative 7, and then x to the 4th power, y to the 4th power. Again, the degree there would be 8 for that term. Then your next highest degree would be 7, and that's going to occur where you have x to the 4th power y cubed. So we're going to see that here and then also here. So again, if I put a coefficient of 1 here, because that's implied, you would have 1 plus 8, which would give me 9. So let me put plus 9 here. And then the variables are going to come along for the ride. So just the x to the 4th power y cubed. Okay, so that's taken care of. So now when I go down the list, I'm looking at this guy has a degree of 2, right? The xy, so minus 6xy. And then you have the 2xy. Okay, so I want that one next. So basically, negative 6 plus 2 is going to give me negative 4. Let me change colors here. I'll put maybe a black. So we'll go minus this 4xy. And then lastly, I have this y here, nothing to combine with it, so I'll put plus y. Again, when you have two variables involved, just get with your teacher in terms of standard form. But the way I did this was I'm listing this guy first because the degree is 8, this guy second because the degree is 7, this guy third because the degree is 2, and this guy has a degree of 1. Okay, so that's why I get my answer in this way. And so I'm going to read this as negative 7x to the 4th power y to the 4th power plus 9x to the 4th power y cubed minus 4xy and then plus y. All right, let's look at our little practice test. So we're told to find each product, and for the first problem, we have 2 multiplied by the quantity 4x plus 2. Okay, so when you see a scenario like this, you're just going to use your distributive property. So I'm going to distribute this 2 to each term inside of the parentheses. So let's go ahead and set this up the long way. We'll have 2, and I'm going to put multiplied by 4x, and then plus I'll have 2 times 2. Now, when you multiply, what you're looking to do is combine what you can. So in other words, if you have a number times a number or a variable times a variable, you're looking to combine what you can. So in other words, 2 times 4, if I multiply these numbers together, I'm going to get 8. And then x, I really can't do anything other than just to list that. So I always say x comes along for the ride. Then you have your plus. You have 2 times 2, which is going to give you 4. And 8x and 4 are not like terms, so this is as simple as we can make this. So our answer is going to be 8x plus 4. Okay, let's look at the second problem. Very similar setup. So we have 5x cubed multiplied by the quantity 3x plus 2. Okay, so I'm going to distribute this 5x cubed to each term inside of the parentheses. So let me write this out. I'll have 5x cubed times 3x, and then plus I'm going to have 5x cubed times 2. So to show this, and I'm only going to do this for this problem, after this we'll kind of pick up the pace, I'm going to use my commutative property to change the order of things. So let me put the numbers next to each other. I'm going to put 5 times 3 like this, and then I'll put the variables next to each other. So x cubed times, I'm going to go ahead and write this as x to the first power. Then plus, I'll go 5 times 2, and then I'll put times my x cubed like this. Okay, so from here, I think it's more clear what we need to do. We have the numbers here that we can multiply together, or the coefficients as we call them. So 5 times 3, if I did that, that would be 15. And then x cubed times x to the first power, again, keep the base the same, so x stays the same, and you want to add your exponents. So 3 plus 1 would give me 4. So this is 15x to the 4th power. Then plus, we have 5 times 2, which is 10, okay? And then x cubed just comes along for the ride. Let me make that a little bit better. And basically what we have here is 15x to the 4th power plus 10x cubed. These are not like terms, so this is as simple as I can make this. Okay, let's look at problem number 3. So this is where we basically have two binomials being multiplied together. later on we'll see that for this particular scenario, we could write this quantity 3x minus 2 times the quantity 3x minus 2. We could say this is 3x minus 2, this quantity squared. And we'll have a special formula to deal with this. But for right now, let's do this the long way. And I'm going to use a process called FOIL. Okay, so with FOIL, it's the first terms. So 3x times 3x. So that would be 3 times 3, which is 9. And then x times x is x squared. It's the outer terms. So 3x times negative 2. So that's going to be minus 3 times 2 is 6. X comes along for the ride. The inner terms, or the inside terms as some people say. So you have negative 2 times 3x. That would be minus 2 times 3 is 6. And then you get your x there. That comes along for the ride. And then your last terms. So negative 2 times negative 2, which would be positive 4. So we're not done here because we do have like terms. So we're going to have these like terms inside. So what we want to do is we want to go 9x squared. And then negative 6x minus 6x would be minus 12x. And then we would have plus 4. Okay, so no more like terms. So this is our answer. 9x squared minus 12x plus 4. All right, let's look at problem number 4. So again, we have the product of two binomials. We have this quantity x plus 5 times this quantity 4x minus 1. So we're going to do the first terms. X times 4x would be 4x squared. We're going to do the outer terms, or the outside terms, as some people would say. X times negative 1 would be minus x. The inside terms, we'd have 5 times 4x. 5 times 4 is 20. Let me put plus 20. And the x would come along for the ride. And then the last terms, you have 5 times negative 1. That would be minus 5. So again, when you perform this operation, you see that you have these like terms in the middle from doing the outer terms and the inside terms. So what we want to do is just simplify here. So I'll have my 4x squared. Negative x plus 20x, again, you could put a little 1 there, so this becomes negative 1. So negative 1 is the coefficient here, and 20 is the coefficient here. Negative 1 plus 20 is positive 19, so plus 19x, and then minus 5. So no more like terms. We get 4x squared plus 19x minus 5. Let me make that a little bit bigger so that it's more clear. Okay, let's look at problem number 5. Again, the product of two binomials. So we have the quantity 4x plus 4 times the quantity 5x plus 3. So again, we're going to do the first terms. 4x times 5x, again, 4 times 5 would be 20. X times x would be x squared. The outside terms, you'd have 4x times 3. So that's plus 4 times 3 is 12. X comes along for the ride. The inside terms, 4 times 5x, will go plus 4 times 5 is 20. And then x comes along for the ride. And then plus, we want to do the last terms. 4 times 3 would be 12. So again, we see we have these like terms that are going to be the result from the outer terms and the inner terms. Okay, so we want to combine those. And what we're going to get, let me put equals here. You'll have your 20x squared. And then we have 12x plus 20x. So 12 plus 20 is going to give me 32. So plus 32x. And then lastly, we're going to have plus 12 here. So my answer here is 20x squared plus 32x plus 12. No more like terms to combine, so this is as simple as we can make it. Okay, let's look at problem number 6. So we have the quantity 5x plus 2 times the quantity 2x plus 3. So again, we can just use FOIL here. So we're going to do first terms, 5x times 2x. 5 times 2 is 10. Then x times x is x squared. Then the outer terms, or the outside terms, 5x times 3 is going to be 5 times 3 is 15. X comes along for the ride, so 15x. And then the inside terms, we're going to have 2 times 2x. 2 times 2 is 4. X comes along for the ride. And then for the last terms, we have 2 times 3, which is just 6. Again, I have like terms right here. Okay, so I can go ahead and combine those to get my final answer. We'll have 10x squared plus 15 plus 4 is going to give me 19, and then times x, and then plus 6. So we have our 10x squared plus 19x plus 6. Again, no like terms there, so we can go ahead and say that's our simplified answer. Okay, let's look at something that's a little bit more tedious. So now we don't have the product of two binomials. We cannot use FOIL if we're outside that situation. So what we have here for problem number 7 is the quantity 2x squared minus 3x minus 4 times the quantity 5x minus 1. So what I'm going to do is I'm going to take each term of this binomial here, and I'm going to multiply it by each term of this trinomial here. And once I'm done with that, I'm just going to combine like terms. So in other words, I'm going to say, let me write this out. So 5x multiplied by the quantity 2x squared minus 3x minus 4. Then I can do plus. This is a -1, so some people will put -1 there. It's really up to you. I'm going to just put plus and then -1 here so I don't make a sign mistake. And actually, let me write this down here so it all fits. And then I'm going to multiply by this quantity, 2x squared minus 3x minus 4. So we'll go through and do each of these, okay? And then we'll combine any like terms. So let me put equals. Let me scroll down a little bit. So 5x times 2x squared is going to be what? That's going to be 5 times 2, that's 10. X times x squared is x cubed. Then we'll have 5x times negative 3x. That'll be negative. 5 times 3 is 15. X times x is x squared. Then I have 5x times negative 4. That's going to be negative. 5 times 4 is 20. And again, x just comes along for the ride. Let me make this 2 a little bit cleaner. Then we have this -1 multiplied by 2x squared. That's just going to change the sign, right? When you multiply something by -1, you're just changing the sign. So really, if I want to do this quickly, I can look at each term and just change the sign. Okay, that's all I need to do. So I can put minus 2x squared. I can do plus 3x, and I can do plus 4. Again, if I'm distributing this -1 to each term inside the parentheses, this would become negative, this would be positive, and this would be positive. So that's all I did. So now what I want to do is look for any like terms and just combine those guys. Well, I have 10x cubed. Let me write that out in front. So 10x cubed. And then I have x squared, and that's going to be on this term here, this -15x squared, and this -2x squared. So combining like terms there, -15 minus 2 would be -17 or minus 17, and this would be x squared. And then let me erase this and this. The next guy would be x to the first power, so you've got -20x, and you've got positive 3x or plus 3x. So -20 plus 3 is -17, so you'll have minus 17x. And then lastly, you just have this constant term 4 here, and nothing to combine with it, so plus 4. So no other like terms here to combine, so we get 10x cubed minus 17x squared minus 17x plus 4. All right, let's look at problem number 8. So we have the quantity 5x squared minus 3x minus 1 multiplied by the quantity 4x minus 1. So again, all I'm doing is I'm taking each term from this binomial here and multiplying it by each term of the trinomial here. And when I'm done, I'm just going to combine like terms. Okay, that's all I'm doing. So I'm going to take 4x, and I'm going to multiply it by the quantity 5x squared minus 3x minus 1. And then let's go ahead and say plus, I'll go -1, okay, multiplied by, again, this quantity 5x squared, and then minus 3x, and then minus 1. The fact that we have a -1 here or a -1 here makes this process really quick when we get to that second part. So let me put equals here, and I'm just going to go through and multiply this. So we have 4x times 5x squared. 4 times 5 is going to be 20. X times x squared is x cubed. Let me make that a little bit better. So x cubed like this. And then you have 4x times -3x. So let me put minus there. 4 times 3 is 12. X times x is x squared. And then 4x times -1 is minus 4x. Again, because this is -1 that's multiplying each term here, all I have to do is just change the sign. Okay, so it's really, really simple. So I'm going to have a minus 5x squared, a plus 3x, and a plus 1. So I just changed the sign of this term, and this term, because multiplying by -1 just changes the sign. So let's see what we can do here. Let me scroll down and get a little bit of room. See if we have any like terms we can combine. So first I have this 20x cubed, nothing to combine with that. Then I'm going to have, and let me make this 3 a little bit better. Then I have -12x squared. Let me highlight this. So -12x squared and -5x squared. I can combine those like terms. -12 minus 5 would be -17. So this is minus 17x squared. Okay. And let's get rid of this and this. And then what I'm looking at next would be this -4x and this positive 3x. So -4 plus 3 would be -1. So this is minus x. And let's get rid of this highlighting and this highlighting. And lastly, I have plus 1, that constant term. There's nothing to combine with that. So my simplified answer here is 20x cubed minus 17x squared minus x plus 1. Okay, let's look at problem number 9, which has 2 variables, so it makes it a little bit more tedious. So we have the quantity 6x squared plus 6xy minus 8y squared multiplied by the quantity 7x plus y. Okay, so the idea here is the same. I am going to just take each term of this binomial and multiply it by each term of this trinomial. And when I'm done, I'm going to combine like terms. So I'm going to take 7x and multiply by the quantity 6x squared plus 6xy minus 8y squared. Okay. Then I'll go plus, I'll have this y. Let me do this down here. It's never going to fit. So y multiplied by 6x squared plus 6xy minus 8y squared. Okay, so I'll just tell you in advance this is going to be pretty tedious. Let's come down a little bit and get some room. So we're going to start with 7x times 6x squared. So 7 times 6 is 42. 7 times 6 is 42. X times x squared is x cubed. Then plus 7x times 6xy. 7 times 6 is 42. X times x is x squared. And then you have y that's just going to come along for the ride. Then you have 7x times negative 8y squared. So I'll put minus here. 7 times 8 is 56. And then x and then y squared. Those are just going to come along for the ride. Okay, so that part's done. Let me switch ink colors here so we can keep this separated. Let me scroll down just a little bit. So down here, I'm going to have y times 6x squared. Really, I'm just going to have plus 6x squared y. And then plus, I have y times 6xy. So 6x, y times y is y squared. And then you have y times negative 8y squared. So minus, I'll put 8. Y times y squared is y cubed. Okay, so let's scroll down a little bit. Again, we're going to get into some issues with standard form. As I talked about a lot so far in this course, depending on your textbook and your teacher, if you have two variables involved, they might not care at all about standard form, so you might be able to list things in any order and not lose any points. Some teachers have a very specific way that they want things. So once again, I'm going to tell you the way that I was always taught or what I've come to understand. So basically, you want to list things in terms of the degree. So the highest degree is going to go all the way to the left. And then if there's a tie, you basically have some sort of alphabetical order. So x comes before y in the alphabet. So you want to look for the term with the highest exponent on x. Okay, that would come next. All right, so with that being said, let's look at our degrees. We have a degree of 3, 3, this is 3, this is 3, this is 3, and this is 3. So you can see that everything has a degree of 3. So what I'm going to do is I'm going to look for the highest exponent that occurs on x, and that occurs here with this x cubed. I don't have anything to combine with this 42x cubed, so I'm just going to write this all the way out to the left, so 42x cubed. So we've used that, okay? And I think when you get some tedious problems like this, you might want to put maybe a check mark or something to show that you've used it. So the next guy that I'm going to look at is going to have an x squared in it, so x squared y. Let me highlight these. So 42x squared y. And then we have not this one, but this one, 6x squared y. And then that's basically going to be it for those two. So 42 plus 6 is going to be 48. So let me put plus 48x squared y. Let's erase this and this. And I'll put a check mark here and here. So next, you would have x to the first power. Okay, so x to the first power y squared, x to the first power y squared. Okay, so let me highlight this one and this one. And so negative 56 plus 6 would be negative 50. So let's put minus 50xy squared. Okay, I'm going to put a check mark here and here. And let's erase this and this. And lastly, I'll put a check mark here because we're going to use it. Let me kind of scooch this down a little bit so it all fits. Lastly, we're going to have this minus 8y cubed. Okay, nothing to combine with that. Now, if you get a different answer in terms of your order, that's up to you. Okay, again, from different textbooks, you'll see different things when two variables are involved, but this is how I'm going to choose to list my answer. So 42x cubed plus 48x squared y minus 50xy squared minus 8y cubed. All right, let's look at problem number 10. So we have the quantity x squared minus xy minus 5y squared times the quantity 2x squared minus 5xy plus 2y squared. So again, all you're doing here is using the distributive property in the end. So each term of this left polynomial needs to get multiplied by each term of the right polynomial, and you need to combine like terms, okay? With this, since you have two trinomials, you can just take and set this up as, let's just start with the leftmost guy. So I'm going to take x squared here, which is the first term of this left polynomial, and multiply by each term of this right polynomial. So times the quantity 2x squared minus 5xy plus 2y squared, okay? Then I'm going to go plus, so let's put the plus here. This is negative, so let's go ahead and put minus xy here times the quantity 2x squared minus 5xy plus 2y squared. Let me put plus, and then I have my minus 5y squared times the quantity, again, this 2x squared minus 5xy plus 2y squared. Okay, so now that we set all that up, let me scroll down, get some room going, and we'll crank this out. So we'll start up here. So x squared times 2x squared would be 2 would stay unchanged. X squared times x squared would be x to the 4th power. Then we have x squared times negative 5xy. We'll put a minus there. And basically 5 stays unchanged. X squared times x is x cubed. And then you have your y. Then plus, you have your x squared times 2y squared. You'd have your 2x squared y squared. Okay, not much you can do there. All right, then when we put this plus here, or actually, I can leave that off because this first term's going to be negative. So we'll start off with a minus. So we have the negative xy multiplied by 2x squared. So let me put minus here. We have the 2, and then we have x times x squared, which would be x cubed. And then we have our y that would just come along. Okay. Then we have negative xy times negative 5xy. That's going to give me a plus. And basically, I'll put the 5 there. X times x is going to be x squared. And y times y is going to be y squared. Okay? So then now we have this negative xy times 2y squared. Let's put minus 2. And then I'll have x. And then y times y squared is y cubed. Then for the last part here, let me scroll down and get some room going. For, again, the last part here, negative 5y squared times 2x squared. We'll put a negative or minus there. 5 times 2 is 10. And then you just have x squared, y squared. And then you have negative 5y squared times negative 5xy. So negative times negative is positive. And then 5 times 5 is 25. Let me get rid of that and make that a little bit better. So that's 25. And then you have x that's going to come along. And y times y squared is y cubed. Okay, so now, lastly, I have this negative 5y squared times 2y squared. So this would be negative. 5 times 2 is going to be 10. And then y squared times y squared is y to the 4th power. Okay, so let's put equals there. I didn't put that, so let's put equals here. Let me scroll down and get some room going. So again, if you want to use my definition of standard form, you can go with that. If you have your own or your teacher tells you something different, go with that. I'm going to look for the term with the highest degree. So this is a 4. This is a 4, 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 and this is a 4. So once again, we have this big fat tie. So that means I'm going to look for the exponent on x, that's the largest, because x comes before y in the alphabet. So you'll see you have this 2x to the 4th power here, okay? Is there anything that I can combine with that? It doesn't look like there is going through there. So I'm just going to start by listing that. So let's put our 2x to the 4th power like that. And again, I like to check these off as I use them, just so I don't come back to things. Okay, so the next guy, I'm going to look for x cubed. So I'm going to have this negative 5x cubed y. I'm going to have this negative 2x cubed y. That looks like it's it for that. So negative 5 minus 2 is negative 7. So minus 7x cubed y. Okay, let me put the check mark there and there. Let's get rid of that and get rid of that. So then I'm going to look for x squared. So it looks like I'm going to have this 2x squared y squared. I'm going to have this 5x squared y squared. And I'm going to have this negative 10x squared y squared. Okay, so 2 plus 5 is 7. And then 7 minus 10 is negative 3. So let's put minus 3x squared y squared like this. I'm going to check this off, and this off. Let's get rid of this, and this, and this. Okay, and so now what do I have left? I'm going to go with this guy right here, this negative 2x to the 1st power y cubed, this 25x to the 1st power y cubed. Let's go with that. So negative 2 plus 25 is 23. So plus 23x y cubed. And let's scoot this down a little bit, otherwise it will not fit. Did not mean to do that. And so lastly, let me get rid of this highlighting here. Get rid of that there and there. I'm going to check this off and check this off. You can check this off. There's nothing to combine with that. So I'm just going to put minus this 10y to the 4th power. So again, this is my version of standard form that I've come to understand. If you have a different way to list things, that's really up to you. I've never seen a teacher mark points off when two variables are involved. So we have 2x to the 4th power minus 7x cubed y minus 3x squared y squared plus 23xy cubed minus 10y to the 4th power. All right, let's take a look at our little practice test. So we're told to find each product. And for problem number 1, we have the quantity 3x plus 7 times the quantity 3x minus 7. So the strategy here is to use our little shortcut formula. Remember, these two binomials are called conjugates. The difference between them is just the sign, right? So this is a plus here and this is a minus here. If you look at the first position of each, it's a 3x and a 3x. If you look at the last position of each, it's a 7 and a 7. So the idea here is if you used FOIL, your result from doing the outer terms and your result from doing the inner terms, those are going to cancel, right? So in other words, if I did this step here, this is negative 21x. This step here is positive 21x. So those are going to cancel. So you could basically just skip that part, okay? So all you really need to do is the first terms, okay, and then minus your last terms. So the formula, the way we write this, let me kind of get rid of this real quick. If you see something like, let's say a plus b times this a minus b, so this quantity a plus b times this quantity a minus b, this becomes a squared, so the first guy here squared, minus b squared, so the last guy here squared, okay? You're skipping the outer and the inner, right? Those two guys, and you're just making this quicker because you know those are going to cancel. So for this guy, all I got to do is take the first guy, which is 3x, so 3x, and I'm going to square it, okay? Then minus my last guy, which is 7, and I'm going to square it. So a common mistake here is just to write 3x squared, but actually you need to square the 3 and the x. That's how this works. This is applied to each factor. So we're going to say that this is 3 squared, which is 9, times x squared, so this would be x squared, so 9x squared there. And then minus your 7 being squared is just 49. So this would be 9x squared minus 49. Again, if you wanted to check this with FOIL, you can pause the video and you'll see you get the same answer. Okay, let's look at problem number 2. We have the quantity 5x minus 6 times the quantity 5x plus 6. So again, I have conjugates here, so I'm just going to use my formula. I'm going to square this 5x. That's my first guy. Then minus, I'm going to square my second guy, which is 6. So square that. 5x being squared, again, the 5 is squared and so is the x. So 5 squared is 25, and then x squared is just x squared. And then minus 6 being squared is 36. So that's going to be my answer, the 25x squared minus 36. All right, let's look at problem number 3. So we have the quantity 6x minus 1 being squared. So I want you to recall in the lesson, we talked about a little formula for this. So let's say it has something like x, I'm going to start with x plus y quantity squared. This is the first guy, which is x being squared, plus 2 times the first guy times the second guy. So 2 times xy, and then plus the last guy, which is y being squared, okay? If you have a sign change here, so x minus y, quantity squared, this is x squared minus 2xy plus y squared. So only the sign is going to change here and here, okay? That's the only difference. Now, one thing I want to call your attention to with this problem, do not do this common mistake. So the most common mistake is to put equals. People will take, okay, I'm going to take this 6x and I'm going to square this, and then minus, I'm going to take this 1 and I'm going to square this. This is not correct. So this is not correct. That is wrong, okay? You don't want to do that. You can't apply this exponent when you have a minus or a plus inside of there. Very common mistake. You can only do that if you had something like, let's say I had 6, and for clarity, I'm going to put times x and then times 5 like this, and I squared that. Well, we know that there's a rule where this exponent applies to each inside, right? Each factor. So this is equal to 6 squared times x squared times 5 squared. So you can do that with multiplication. But if this is subtraction or addition, you cannot do this, okay? You have to actually legally expand this into the quantity 6x minus 1 times the quantity 6x minus 1. So this must be expanded. Now, with this expansion, you're going to be able to use this little shortcut here, because what ends up happening is you have the first guy that's squared, right? So 6x times 6x, it's the same term, so that guy is just squared. So I'm going to take this 6x and I'm going to square it. Then, basically, you think about the outside and the inside. Well, you have 6x times negative 1 in each case. It's just done in a different order, right? So I might as well just say that I have 2 times that amount. So we're going to have minus 2 times the 6x multiplied by the 1. So in other words, minus 2 times the first guy times the second guy. So the 6x times the 1. Then lastly, I have these last terms here. I have a negative times a negative, right? So I know this is going to be plus, and then I can just do this 1 times 1, or 1 squared. So this is where we use our formula, and I'll do this once more so it's completely clear. So let's come down here. I'm just going to erase this for right now, and let's just go through and see what we have. So 6x being squared. Again, this exponent now applies to the 6 and the x. So 6 squared is 36. X squared is just x squared. Then minus, you have 2 times 6x times 1. So 2 times 6 is 12. So this would be 12 times x. And then plus, lastly, you have your 1. So the answer here would be 36x squared minus 12x plus 1. Again, the formula is the first guy being squared. So 6x being squared minus 2 times the first guy times the second guy. So 2 times 6x times 1, and then plus your last guy, which is 1 here squared. Because it's going to be a negative times a negative, we know this would be a plus here, okay? So plus, just take this guy right here and square it. So that's how we get our 36x squared minus 12x plus 1. Okay, let's look at problem number 4. So we have the quantity x plus 6 being squared. Again, now this is a plus. So again, I'm just going to write this out. So x plus y quantity squared, it's x squared plus 2xy plus y squared. If you do this enough times, you will memorize this, and it's perfect because it helps you so much on solving problems because these come up all the time. So I'm going to take this first guy, which is x, and I'm going to square it. And then plus, I'm going to go 2 times the first guy times the second guy. So what is 2 times? Let me write this out. So 2 times the first guy times the second guy. Then plus the last guy, which is 6, being squared. So what does this give me? I have x squared plus 2 times 6 is 12. So that's 12 times x plus 6 squared is 36. Again, you can always expand this and use FOIL. So you could say this is the quantity x plus 6 times the quantity x plus 6. You're going to get the same answer either way. So you'll get x squared plus 12x plus 36. Okay, let's look at problem number 5. So we have the quantity 7 plus 6x times the quantity 7 minus 6x. So we're back to multiplying conjugates. So let's go ahead and take the first guy, which is 7, and that's going to be squared. And then minus, we're going to take the last guy, which is 6x, and that's going to be squared. Again, that's just from our formula. So we'd end up with 49 minus. If I square 6, I get 36. If I square x, I get x squared. So typically, you could leave it like this, or again, your teacher might want you to write this in standard form. Either way, it's the same answer. It's just the way we structure it. So I'm going to write this in standard form as negative 36x squared and then plus 49. But again, if you want to write it like this, just for clarity, to stay consistent with the formula, that's really up to you. Okay, let's look at problem number 6. So we have the quantity 2x squared plus 3, and this is being squared. Okay, so again, I'm going to use my formula. Square the first guy. So the first guy is 2x, and that's squared actually. So let me make sure I make that clear. And then this is squared. So 2x squared is squared. Okay, this whole thing is being squared. Then we're going to have plus 2 times this guy, 2 times 2x squared, times this guy, so times 3, and then plus the last guy, which is 3, being squared. So again, I'm going to write this out one more time. So x plus y quantity squared is x squared plus 2xy plus y squared. Just keep writing that over and over again, and then you'll memorize it, and this will be really, really quick for you. Okay, so for this guy, if I had 2x squared being squared, again, 2 gets squared, so that's 4, and then x squared gets squared. Again, power to power rule, x stays the same. 2 times 2 would be 4, so this would be 4x to the 4th power. Then plus 2 times 2 times 3, 2 times 2 is 4, 4 times 3 is 12, and then x squared would come along for the ride, and then plus, we know 3 squared is 9. So we end up with 4x to the 4th power plus 12x squared plus 9. All right, let's look at problem number 7 now. So we have the quantity 8x minus 2 being cubed. Okay, so I want to just call your attention one more time to the common mistake. You do not want to say this is equal to the 8x being cubed minus the 2 being cubed. Again, this is 100% wrong. Please don't make this mistake. It's very common. This is a difference. So if you have a difference there or a sum, you cannot distribute that exponent to each term. It just doesn't work that way, okay? So you have to expand this if you want to do it the long way. So you have to go 8x minus 2, this quantity, times the quantity 8x minus 2, times the quantity 8x. Let me make that better. So 8x minus 2 like this, okay? But of course, we're not going to do this because this would take forever, and we have a little shortcut, okay? So in the lesson, we talked about if you had something like, let's say, x plus y quantity cubed, this would be x cubed plus 3x squared y, plus you'd have 3xy squared plus y cubed. Now, this is something I've already committed to memory. In terms of this formula, it's more difficult to memorize this than the other ones, so it is something you do have to practice with, and that's all you have to do, you just have to practice. Then for the other one, x minus y quantity cubed, this is going to be x cubed. Let me write all the terms. So 3x squared y, 3xy squared, and y cubed. So the terms are the same, it's just the signs. So in front of the second and fourth terms, so in front of the even terms, you're going to have negatives or minus. So minus, and then in front of the first and third or the odd terms, you're going to have a plus, right? There's no visible plus there, but I just think about it as being positive. Okay, so these are the formulas, and we can just use this second one here for this guy here. So I want to take the first guy, whatever's in this position here, and I want to cube it, okay? So I want to take 8x and I want to cube the whole thing, both the 8 and the x, okay? So here's where you can apply the exponent of 3 to both. Not when you have a sum, but when you have a product like we have there, okay? So then we want to have minus we have the 3 times the x squared. Again, what's x? It's what's in the first position. So that's going to be this 8x, and I'm going to square that guy, and then times the y, that's whatever's in the last position. So this is my 2 there. So then plus, we have our 3 multiplied by, what is x? It's whatever's in the first position, so this is 8x, and then times your y being squared. Why is that 2 there? It's whatever's in the last position, so that's going to be 2 squared. Let me put that out like this, so 2 squared. And then finally minus y being cubed. Well, again, y represents what's in the last position, so this is 2 being cubed, okay? Let me cut these formulas away. We'll use them on the next one. And so let me put equals here. So 8x cubed, again, 8 is being cubed and so is x. So 8 cubed is 512. Again, you can use a calculator for that, no big deal. So 512x cubed, and then minus, you're going to have 3 multiplied by, this 8x is being squared. So 8 squared is 64. That's 64. And x squared is just x squared, and then times 2. So you basically have negative 3 times 64 times 2, which would be negative 384. So let's put negative 384, and then x squared there. And then plus, now you have 3 times 8x times 2 squared. 2 squared is 4. So let me write this out. So 3 times 8 times 4 times x. 3 times 8 is 24. 24 times 4 is 96. So this would be 96x. So 96x. And then minus 2 cubed is going to be 8. So this would be our answer. Of course, this formula is something that can give you a lot of trouble with memorization. It's something you just need a lot of practice with. So we get 512x cubed minus 384x squared plus 96x minus 8. Okay, let's look at problem number 8. So we have the quantity 5x plus 1 being cubed. Again, let me paste this little formula and bring that back in for us. So now we want the top one here. Again, when we talk about x, it's whatever this first position is. When we talk about y, it's whatever is in this second position here. So you just basically replace everywhere there's an x with 5x, and you replace everywhere there's a y with 1. Okay, that's all you're doing. So let's just go ahead and say the first guy, so 5x, is going to be cubed. And then we're going to have plus, we're going to have 3 multiplied by the first guy squared, so 5x being squared, times the second guy, which is 1. Then plus, we're going to have 3 times the first guy, which is 5x, then times the second guy, which is 1, being squared. And lastly, plus this guy, this last guy, 1 being cubed. Let's put equals. Again, let me get rid of this. So 5x being cubed. Again, 5 is being cubed and so is x. This is 125x cubed. Then plus 5 is being squared, that's 25. X is being squared, that's x squared. So I would have 25 times 3, that's 75. Then times x squared. Of course, you multiply by 1, but that doesn't change anything. So then plus, you can really just say 1 squared is obviously 1. That's not going to change anything. So 3 times 5 is 15, then times x, and then plus 1 cubed is just 1. So we get 125x cubed plus 75x squared plus 15x plus 1. Okay, let's look at problem number 9. So we have the quantity 3x squared minus y squared, and this is cubed. Okay, let me bring this formula back so that we have it. Now we're using this bottom one again. So what I want to do, let me actually erase this one so it's going to fit on the screen. This will probably take up a lot of room. Let me move this up just a little bit so you can see it. So again, x is going to now be 3x squared. So everywhere there's an x, you're plugging in 3x squared. Y is now going to be y squared. So everywhere there's a y, it's going to be y squared, okay? You're just plugging into the formula. That's all you're doing. So the first guy here is going to be cubed. So 3x squared is going to be cubed, okay? It's just from right here. Then I'm going to have a minus sign, okay, because there's a minus there. You have 3 times the first guy. So this 3x squared, so times this 3x squared being squared, okay? Then times this guy here, the second guy, which is y squared. Then we're going to have plus. Let me put this down here. We're going to have 3 times. We're going to have this first guy, which is the 3x squared, then times the second guy, which is y squared being squared. Then lastly, we're going to have minus. We're going to have this final guy, which is y squared, so y squared, and this is going to be cubed. So let me get rid of this. Again, if you're not at the point where you've 100% memorized the formula, it's okay. Just keep working the problems. It's going to come. So let's go ahead and select this. So 3x squared being cubed. So 3 is cubed. That's 3 times 3 times 3, which is 27. X squared is cubed. X stays the same. 2 times 3 is 6. Then minus. So let's go ahead and say this is 3x squared being squared. 3 is squared, that's 9. Let me write this out. So 9. X squared is being squared, that's x to the 4th power. X stays the same. 2 times 2 is 4. Okay, so then we'd have y squared, and we have this 3 that's multiplying this. 3 times 9 is obviously 27. So this would be minus 27 x to the 4th power y squared. So let's scoot this down like this. Okay, then we have plus. So you're going to have 3 times 3, that's 9, then times x squared, then times your y squared squared. So y stays the same. 2 times 2 is 4. Let me scooch this down so we can fit it on the screen. Then lastly, you're going to have minus. You have y squared being cubed. So y stays the same. Multiply exponents. 2 times 3 is going to give you 6. So my answer here is 27x to the 6th power minus 27x to the 4th power y squared plus 9x squared y to the 4th power minus y to the 6th power. All right, let's look at problem number 10. So we have the quantity 5x squared plus 3y to the 4th power, and this is cubed. Okay, so I unfortunately erased my formula, so I just need to write it again. So the quantity x plus y being cubed is equal to, again, it's going to be x cubed plus you're going to have your 3x squared y plus your 3xy squared. Let me erase this too and make it a little bit more clean. And then lastly, plus your y cubed. Okay, so with that being said, let's go through and knock this problem out. Again, all you're doing is you're taking whatever is in the first position. In this case, it's 5x squared. You're going to plug that everywhere there's an x. So here and here and here. And then you're taking whatever is in the second position. So 3y to the 4th power. You're going to plug that in here and here and here. And then from there, you're just simplifying. So it's pretty easy overall. It's just a matter of committing this formula to memory and knowing how to plug into it and use it. So let's go ahead and start by taking the first guy. Let me just erase this so it's more clear. The first guy, which is 5x squared, and I want to cube it. So I want 5x squared, and I want to cube that. Then plus, now we're going to have 3 multiplied by, for x, it's going to be 5x squared, so times 5x squared, and I want that to be squared. So I want this squared, and then times, this y here is the 3y to the 4th power, so times 3y to the 4th power. So then plus, now I have my 3 again, and it's just x now, so whatever's in the first position, so times 5x squared, and then times, I have this y squared. So whatever is here, I want to square it. So 3y to the 4th power will be squared. Lastly, plus, you have this y cubed, so whatever's in the second position, just cube it. So that's going to be 3y to the 4th power being cubed. All right, let me erase this. Hopefully you've written that formula down. It's just something you want to maybe put on a flashcard or just work lots and lots and lots of problems. Keep writing it before you work the problem each time, and again, you'll memorize it. So going through this, we would want to cube 5, which would be 125, and then x squared being cubed, x stays the same. Multiply exponents, 2 times 3 is 6. So let me put 125x to the 6th power, and then plus, let me go ahead and square this first. So 5 squared is going to be 25. Let me write this here as 25. X squared squared is x to the 4th power. X stays the same. Multiply exponents, 2 times 2 is 4. So what you'd have here is 3 times 25. That's 75. And then 75 times 3 is 225. So let me put 225. We will have our x to the 4th power and then y to the 4th power. Let me get rid of this. We don't need that anymore. Over here, let me put plus. Over here, I'm going to do this 3y to the 4th power being squared first. So we know 3 squared is 9. Y to the 4th power being squared would be y to the 8th power. Again, y stays the same. Multiply exponents. 4 times 2 is 8. So what I'd have here is 3 times 5 times 9. Well, let me go ahead and do 3 times 5 first. That's 15. And then 15 times 9 is 135. So then you would have your x squared and then y to the 8th power. So let me get rid of this. And then lastly, I'm just going to change colors here. Lastly, I have this 3y to the 4th power being cubed. So 3 cubed is obviously 3 times 3 times 3, which is 27. And then y to the 4th power being cubed, y stays the same. Multiply exponents, 4 times 3 is 12. Now, it's perfectly acceptable to leave your answer in this format. It's fine. Again, most teachers do not have a standard form definition when there's 2 variables. But what I've always been taught, or what I try to follow, I don't always do it myself, I try to put it to where the term with the highest degree is on the left, okay? So what I would do here is I would say 27, y to the 12th power. Let's put that to the left. And then the next highest degree would be this one, so plus 135. So 135. We have x squared y to the 8th, Okay. And then next we would have this plus 225x to the fourth power, y to the fourth power. And lastly, I'd put plus 125x to the sixth power. So a degree of 12, 10, 8, and 6. Again, this is just me being trivial. A lot of teachers do not care about this, especially when you have two variables. So either way you want to list your answer, I'll just say it's 27y to the 12th power plus 135x squared y to the 8th power plus 225x to the 4th power y to the 4th power plus 125x to the 6th power. All right, let's take a look at our practice test. So we want to find each quotient. And for problem number 1, we're going to have x to the 4th power plus 18x cubed plus x squared. This is divided by, or you could say over, 6x squared. Now we talked about in the lesson, if we're dividing a polynomial by a single term, or what we call a monomial, essentially all you have to do is this. We're going to take each term of this polynomial and divide it by this monomial here. So in other words, I'd have x to the 4th power over 6x squared, then plus I'd have 18x cubed over 6x squared, and then plus x squared over 6x squared. Again, we talked about in the lesson the fact that you could go from this form right here, right? This form right here where we have this common denominator to this form right here, right? Everyone knows we could do x to the 4th power plus 18x cubed plus x squared over that common denominator of 6x squared. So of course we could always reverse the process and put it into this form here. So once it's in this form here, you just go through and simplify each part. Before I get into this, I want to call your attention to two rules that would be extremely helpful in solving these problems that we have not covered yet in our course. So let me go up and show those to you real quick. The first one is called the quotient rule for exponents. So let's say I had something like x to the 4th power over x squared. So if you didn't know this rule, you might go through and say, okay, well, this is x times x times x times x, and this is x times x like this. And essentially, I would cancel this with this and this with this, and I'm left with x squared. But the easier way to do this is to subtract the exponent in the denominator, which in this case would be 2, away from the exponent in the numerator, which in this case would be 4, right? I'm basically taking two factors away from the factors that are in the numerator. That's all I'm doing. If I had something like, let's say, x to the 7th power over x cubed, well, again, it would just be x to the power of 7 minus 3, which is x to the 4th power. That's all you have to do. Now, the other rule, which we'll cover later on, deals with working with a negative exponent. So let's say you had something like x to the power of -1. Well, the way I always teach this is you take the reciprocal of the base, so instead of x, you have 1 over x, and you make the exponent positive. So it's just x to the 1st power now. If you had something like x to the power of -2, again, take the reciprocal of the base, so this is 1 over x, and then it's raised to the 2nd power. Okay, and we'll cover this in more detail later on. Now, returning to this, we want to simplify each part. And we're going to have x to the 4th power over x squared. Forget about the 6 for right now. You can't really do anything with it. So if I had x to the 4th power over x squared, again, x stays the same. You're going to subtract exponents. So 4 minus 2 is going to give you 2. So this would be x squared. So let me erase this. Let me actually show this. This is going to cancel completely. This will be a 2. So this will be x squared over 6. Again, I can't do anything with the 6, so I just write it. Then plus, over here, 18 over 6. This is going to be 3, right? 18 divided by 6 is 3. So let me put a 3 up here. And then x cubed over x squared, again, x stays the same. You're going to subtract 3 minus 2, that's going to give you 1. So basically, this would cancel completely. This would be a 1. So this is just 3x here. And then plus, you have x squared over x squared. Let's put a 1 there. So this is 1 over 6. So my answer here is x squared over 6 plus 3x plus 1 over 6. Let me show you one other thing before we go through the rest of this. And let me scroll up just a little bit so this fits on the screen. We know from basic division with whole numbers that if we want to check our division, we can use multiplication. So for example, if I do something like 6 divided by 2, this equals 3. Well, the related multiplication statement, I could say 3 times 2 gives me 6, right? So in other words, the dividend divided by the divisor gives me the quotient, but the quotient times the divisor should give me the dividend back. So we can use this same principle here to check our work. I could take this guy right here, so this x squared over 6 plus 3x plus 1/6, and I could multiply it by this 6x squared, and I should get my dividend back. So 6x squared times x squared over 6, the 6's would cancel. X squared times x squared is x to the 4th power. So that gives you that right there. Then 6x squared times 3x, 6 times 3 is 18. X squared times x is x cubed, so that gives you 18x cubed back. And then 6x squared times 1 over 6, the 6's would cancel. You have x squared times 1, which is x squared, so that gives you that back. So if you're ever a little bit lost or confused about if you got the right answer, obviously you could use a computer, but if you wanted to check things the old-fashioned way, you could use multiplication. All right, let's take a look at problem number 2 now. So we have 4x cubed plus 2x squared plus 16x, and this is over 4x. So let me put equals here, and let's just split this up again. I'm going to have my 4x cubed over 4x, and then plus I have 2x squared over 4x, and then plus I have my 16x over 4x. So again, I'm just going to simplify each part separately here. That's all I want to do. So over here, 4 divided by 4 is 1. You can just get rid of that. X cubed over x, basically this is x to the first power. Again, this is going to cancel. You subtract the exponents, 3 minus 1 is 2. So this would be x squared here. So x squared, then plus. If we think about 2 and 4, there's a common factor of 2. In other words, 4 divided by 2 would be 2. 2 divided by 2 would be 1. And then x squared over x, again, this is x to the first power. This would just be x to the first power or just x. So this would end up being, you put 1/2 times x, or I'd probably just write this as x over 2. And then plus here, 16x over 4x, the x's are going to cancel. And 16 divided by 4 is 4. Okay, so we'll just put plus 4 here. So we have x squared plus x over 2 plus 4. All right, let's look at problem number 3. So we have 2x cubed plus 5x squared plus 6x. This is over 6x squared. Okay, so again, I'm just going to do my 2x cubed over 6x squared, then plus 5x squared over 6x squared, and then plus 6x over 6x squared. So 6 divided by 2 is 3. So I can write this as 3. You can write this as a 1. And then x cubed over x squared, this is going to cancel with this and give me a 1 here, right? 3 minus 2 is 1. So basically you'd have x over 3. Some people will write this as 1/3 x. It's really up to you. Then plus the x squareds are going to cancel there. You'll have 5 over 6. Then plus the 6's are going to cancel there. And you're going to have something interesting here. If you use the quotient rule for exponents, you would have x to the power of 1 minus 2, which is -1. We talked about earlier that's going to be 1 over x, okay? But again, if you didn't know that rule, you can just look at this and say, okay, well, I have 1x here and I have 2x's here. If I cancel this guy here with one of these guys here, I'm going to have a 1 up here over an x down here. So either way you do it, you get 1 over x for that part. Okay, so let me put equals here. So we have x over 3 plus 5 over 6 plus 1 over x. All right, now let's look at some problems with polynomial long division. So for problem number 4, we have x cubed plus 9x squared plus 19x minus 2, and this is over x plus 3. Now in the next lesson, we'll talk about how to do this much more quickly using something called synthetic division. For right now, we're going to be stuck using this polynomial long division for this problem. So the first thing you want to do is set up your little long division symbol that you're used to working with. So something like this, okay? And you're going to take your dividend, the guy in the numerator in this case, and you're going to write it under this guy. And essentially you want to make sure that number 1, it's in standard form. And number 2, you're not missing any powers. So in other words, if I have x cubed, then I'm also going to have x squared and x to the first power, so on and so forth, okay? So in this case, I'm not missing any powers and it's in standard form. So I'm just going to write x cubed and then plus 9x squared and then plus 19x and then minus 2. Then off to the left, I'm just going to put my x plus 3. Again, you've got to also make sure that it's in standard form and you're not missing any powers. So let's go ahead and grab this. So when you work a long division problem, remember from pre-algebra, we use the D, M, S, B, R. You might want to write that down if you're lost on the steps. It's dad, mom, sister, brother, rover. So that's a little trick to remember it. And it stands for divide, multiply, subtract, bring down, and then repeat or remainder. Okay, but you can remember dad, mom, sister, brother, rover more easily than saying divide, multiply, subtract, bring down, repeat, or remainder. So let's erase this and let's start with our division. Now what you want to do here is leading term, so leading term into leading term. So in other words, I'm asking the question, what is x cubed divided by x? And we know from the quotient rule for exponents, 3 minus 1 would be 2, so this is x squared. Now, I typically will write this over this term right here, which has an x squared involved. Some books will put this all the way to the left. Again, how you write your answer is up to you. If your teacher tells you to do it a specific way, just follow that. In the end, it really doesn't matter. Okay, so I'm just going to put x squared here like this. Now, I've done my division, so I want to multiply. So I'm going to multiply this x squared by both the x and the 3. So in other words, I'm going to do x squared times the quantity x plus 3, like this. So x squared times x is x cubed, and then plus x squared times 3 is 3x squared. So let me write this. This is x cubed, and then it's going to be plus 3x squared. So now that we've done our multiplication, and actually let me erase this and this. Now that we've done our multiplication, we want to do something called subtraction. Now, how do we subtract away a polynomial? We basically change it to addition of the opposite. So I'm going to change this sign to minus. I'm going to change this sign to minus. And so from here, we're going to combine like terms. So x cubed minus x cubed would be 0, so you don't have to write anything. And then 9x squared minus 3x squared would be 6x squared. So now that we have this done, we're going to go to the bring down steps. I'm going to bring this guy down, so plus 19x. And then if I brought something down in the last step, I want to repeat the process. So in other words, I want to go back to division, and I want to go leading term into leading term. Let me scroll down a little bit so this fits on the screen. And so what I want to do now is say 6x squared divided by x is equal to what? Well, the 6 would come along for the ride. Nothing to really do there. X squared over x would be x to the first power. So this is plus, we'll have 6x here. So now we're going to multiply. I'm just going to do this more quickly. So 6x times x would be 6x squared. And then 6x times 3 would be plus 18x. Again, to subtract, I'm going to change the sign of this guy and this guy. And now I'm going to combine like terms. 6x squared minus 6x squared, that's 0, so that's gone. 19x minus 18x is positive x, or you can put 1x if you want. And then I'm just going to bring this next term down, so minus 2 here. And then I'm going to do my last division. So I'm going to go leading term into leading term. So you could write this out. Obviously, x over x is 1. So x over x is 1, right? So I'm going to put plus 1 here. And then I'm just going to multiply. So 1 times x plus 3 would just be x plus 3. And then to subtract, I'm going to change this to minus and change this to minus. And then let me do this down here. I'm going to scroll down so we can get some room going. We'll just come back and forth. So basically here you have x minus x, which is 0. And then you have negative 2 minus 3, which is negative 5. So at this point, we normally bring down the next term, but there's no more terms. So basically this guy right here, because it's not 0, is our remainder. So the remainder is going to be negative 5. So let me actually erase everything so it all fits on the screen. So the remainder was negative 5. So we want to write the remainder over the divisor. So we'd want to say you could go minus, you could go 5 over x plus 3 like this, or a lot of people put plus and make this negative. However you want to do it, this is your full answer right here, okay? If you want to report it. So x squared plus 6x plus 1, plus you get negative 5 over x plus 3. Now, I know this is going to take a while, but I do want to show you how you can check this. When you multiply with whole numbers, let's say you did something like 7 divided by 2, well, we know if we punch this on a calculator, you can get 3.5. But before we started doing that, we had remainders, right? So we would say 7 divided by 2 was 3 with a remainder of 1. And the way you get that 0.5 is 1 divided by 2 is 0.5 in decimal form. But essentially, if I wanted to check this result, I could multiply 3 times 2 to get 6, and then I could add the remainder of 1 to get back to 7. Well, it's the same process here. I could multiply this x squared plus 6x plus 1 times this x plus 3, okay? And then when I'm done with that, I could add this negative 5, and I would be back to my dividend. So let's go ahead and do that real quick. I'm just going to do it for this first one because it's a very tedious process. If you don't care about this, just skip this part of the video. Not a big deal. So I'll have this quantity x plus 3 multiplied by this quantity x squared plus 6x plus 1. And when I'm done, I'm going to add negative 5 to it, and I should get this as a result. So let's scroll down and get some room going. I'll come back up. So essentially, I'm going to do x times x squared, that's x cubed. And then plus, I'm going to do x times 6x, that's 6x squared. And then plus x times 1 is just x. And then plus 3 times x squared is 3x squared. And then plus, we're going to have 3 times 6x, that's 18x. And then plus, we're going to have 3 times 1, which is 3. So combine like terms here. You have x cubed that's going to stay there. 6 plus 3 is 9, so this would be 9x squared. So 9x squared, x plus 18x is going to be 19x. So this would be 19x. And then your 3 here, again, you're going to add this remainder of negative 5. 3 minus 5 is negative 2. So this becomes negative 2 here. If I copy this, and let me paste this in here, you can see that you get the same result. X cubed plus 9x squared plus 19x minus 2. So you're back to your dividend. So again, if you ever need to check, if you're just confused, what you can do is you can multiply your quotient times your divisor, and when you're done, take the remainder, okay, and add that in. That's all you need to do to check your work. In some cases, you won't even have a remainder, so you just need to multiply the quotient by the divisor, and that'll give you your dividend back. Okay, let's look at another example. For problem number 5, we have x cubed plus x squared minus 51x minus 42, and this is over your x minus 7. So again, let's just set this up. So x cubed plus x squared minus 51x minus 42. And let's put this over here, so x minus 7. Again, I'll show you how to do this more quickly in the next lesson. This guy qualifies for synthetic division. Okay, so we want to go leading term into leading term. X cubed divided by x is x squared. So let's put x squared right here. Let's multiply x squared times x is x cubed, and then x squared times negative 7 is minus 7x squared. I'm going to change this to minus and this to plus, and we're going to combine like terms. This is 0. X squared plus 7x squared is 8x squared. Bring down this guy, so negative 51x. And then we're going to go, let me erase this. We're going to go leading term into leading term. So what is 8x squared divided by x? Well, the 8 is going to remain unchanged. So we'll put plus 8 here. And then x squared divided by x is x to the first power. Then 8x times x is 8x squared. 8x times negative 7 is minus 56x. So again, I just want to change the sign of each term. This will become minus, this will become plus. If you do your subtraction there, 8x squared minus 8x squared is going to be 0. And then negative 51x plus 56x is going to give me 5x. And then I'm just going to bring down this negative 42, so minus 42. And then I'm going to erase this, and I'll highlight this guy here. So we're going to go leading term into leading term. So 5x divided by x is going to give me 5. So this is going to give me 5. And then 5 times x is 5x. And then 5 times negative 7 is going to be minus 35. All right, so let's change this to a minus and this to a plus. And now we can combine like terms. 5x minus 5x is 0. Negative 42 plus 35 is going to be negative 7. So basically, this is your remainder here. All right, let's just write the answer here. I'm going to go ahead and just say x squared plus my 8x plus my 5. And then again, the remainder was negative 7. So you can either put this minus, you can go 7 over, again, the divisor here is x minus 7. Or if you wanted to, you can go plus and then put a negative 7. Again, it's the same answer either way. All right, let's look at problem number 6. So we have 56x squared plus 8x to the fourth power minus 3 plus 56x. And this is over, or you could say divided by your 8x plus 8. So in this particular case, your numerator here, or your dividend, is not in standard form. You're also missing x cubed. So we need to have a few extra steps here. So first, let me write this as 8x to the fourth power. And then I don't have an x cubed. So what do I want to do? I want to put 0 as the coefficient for x cubed. Again, I've got to have this for my polynomial long division process to work. So then plus, I'll have 56x squared. Let me scooch this down. I don't think it's all going to fit. So then we would have our plus 56x, and then lastly minus 3. So we'll have this guy like this, and then I'll have my 8x plus 8 over here. Let me grab this real quick, cut it away. And again, we're just going to crank this out like we usually do. So again, leading term into leading term. So what is 8x to the fourth power over 8x? 8 divided by 8 is 1. X to the fourth power divided by x is going to be x cubed. So let me write x cubed here. We're going to multiply. X cubed times 8x is going to be 8x to the fourth power. X cubed times 8 is going to be 8x cubed, so plus 8x cubed. So now we want to subtract. So I'm going to make this a minus, and I'm going to make this a minus. So 8x to the fourth power minus 8x to the fourth power is 0. 0x cubed minus 8x cubed would be minus 8x cubed. Then we're going to bring this down, so plus 56x squared. Let me make that a little bit cleaner. And let me make that a little bit cleaner. And now let me erase this. Again, all we're doing is leading term into leading term. So what is negative 8x cubed divided by 8x? Negative divided by positive is negative. And then we would have 8 divided by 8, which is 1. X cubed over x is x squared. So let's put negative x squared. And then we're just going to multiply. Let me erase this now. We're going to have negative x squared times 8x. That's going to be negative. You'll have 8 and then x cubed. And then negative x squared times 8 would be negative 8x squared. I'm going to change the sign of these guys, so plus and plus. Let me put my little bar down here. Negative 8x cubed plus 8x cubed is 0, so that's going to cancel. 56x squared plus 8x squared. 56 plus 8 is going to be 64, so this would be 64x squared. And then I'm going to bring this guy down, so plus 56x. And again, I'm just going to do my leading term into my leading term. Let me scroll down a little bit. So what is 64 divided by 8? That's going to give me 8. What is x squared over x? That's going to give me x. So this would be 8x. Let me come back up. So we'll put plus, we'll have 8x. And I'm going to multiply here. I'm going to have trouble fitting things on the screen. So 8x times 8x would be 64x squared. And then 8x times 8 would be plus 64x. So let me scroll back down. Let's write this in. So 64x squared plus 64x. Let's get rid of that from there. And so what I'm going to do here, again, is just change this to a minus and this to a minus. We can combine like terms. 64x squared minus 64x squared is 0. 56x minus 64x is negative 8x. So let's bring down this next term. I'm going to bring that down there. So let's go minus 3 here. And I'll erase this. And we're going to go, and it's hard to fit this on the screen, so we're going to go leading term, which is 8x, into leading term, which is negative 8x. So what's that going to be? Well, negative 8x divided by 8x is simply negative 1. So let's come up here, and let's put our answer from that as negative 1. We're going to multiply negative 1 times 8x plus 8. You're just changing the sign of each term, so it's negative 8x minus 8. Let's come down here and put negative 8x minus 8. Of course, we change the sign of everything, so this is plus and this is plus. Negative 8x plus 8x is 0. Negative 3 plus 8 is going to be 5. So this is my remainder. So let me put equals, and I'll paste this in. So let's put this over here, and then I'll put plus my 5, which was the remainder, over this divisor here, which is 8x plus 8. So we have x cubed minus x squared plus 8x minus 1, plus you have 5 over 8x plus 8. All right, let's look at problem number 7. So we have x to the 5th power minus 3x to the 4th power minus 23x cubed minus 32x squared minus 18x minus 16 over x minus 7. So this is in standard form, and we're not missing any powers, right? You have 5, 4, 3, 2, 1, and you also have your constant there, so you're good to go. In the denominator, not missing any powers, and you're in standard form. So you're basically ready to roll here. So let's go ahead and put x minus 7 like this. And I'll put this x to the 5th power minus 3x to the 4th power minus 23x cubed minus 32x squared minus 18x minus 16. Okay, let me bring this over. And so basically, again, I'm going to go leading term into leading term. So what is x to the 5th power divided by x? Let me highlight this so it's clear. X to the 5th power divided by x would be x to the 4th power. So let me write that right there. And then x to the 4th power times x is x to the 5th power. X to the 4th power times negative 7 would be minus 7x to the 4th power. Let me change the sign of this guy and this guy. And then we can add x to the 5th power minus x to the 5th power is 0. Negative 3x to the 4th power plus 7x to the 4th power. This is going to give me 4x to the 4th power. So again, now I'm going to bring this guy down. So minus 23x cubed. And then we're just going to repeat the process. So essentially, I want to go leading term into leading term. So what is 4x to the 4th power divided by x? Well, we know this is 4. And then x to the 4th power divided by x is x cubed. Do the multiplication. 4x cubed times x is 4x to the 4th power. Then 4x cubed times negative 7 would be minus 28x cubed. I'm going to change this to plus and this to minus. Let me make that a little bit cleaner. Of course, 4x to the 4th power minus 4x to the 4th power is 0. Negative 23x cubed plus 28x cubed would be 5x cubed. Let me change colors here. And let me bring this down. So we'll have minus 32x squared there. Again, I'm going to do leading term into leading term. Didn't mean to erase that. So I'm going to go 5x cubed divided by x. So of course, I'm going to have 5. So let's put plus 5. X cubed divided by x is going to be x squared. 5x squared times x is 5x cubed. And then 5x squared times negative 7 will be minus 35x squared. So we're going to change this to minus and this to plus. Let me scroll down a little bit. I think we probably can't fit any more on our screen. So of course 5x cubed minus 5x cubed is 0. Negative 32x squared plus 35x squared is 3x squared. Okay, let's scroll up a little bit. Let's get our next term. So we're going to drop this guy, this minus 18x here. And again, let's go ahead and go leading term into leading term. So what is 3x squared divided by x? Well, it's just going to be 3x. So let's come up here and let me put that this is plus 3x. And so we'd have 3x times the quantity x minus 7. So 3x times x is 3x squared. And then 3x times negative 7 is minus 21x. Of course, you're going to change the sign of this to minus and this to plus. And so 3x squared minus 3x squared is 0. Negative 18x plus 21x is going to be 3x. Let's come up here for a moment. I'm going to drop this negative 16 down. So I'm going to drop this negative 16 down. And I put negative 6, so this is negative 16. And we want to go leading term into leading term. So let me erase this. And let me highlight this. So remember, your leading term over here is an x. So let's bring this down here. So 3x divided by x would just be 3. Come back up here. So plus 3, and multiply 3 times the quantity x minus 7. Let's come back down. So 3 times x is 3x, and 3 times negative 7 is going to be negative 21. And so we're going to change this to minus and this to plus. 3x minus 3x is 0. Negative 16 plus 21 is going to give you positive 5. So again, this is your remainder here because there's no more terms to bring down. And then I'm just going to paste this in. I'll put plus, again, the remainder was 5, over this divisor here, which was x minus 7. All right, let's look at problem number 8. So we have 2x to the 4th power plus 10x cubed minus 22 minus 32x. So notice that this is not in standard form and you're missing x squared. Then this is over 4 plus 2x. Again, this is not in standard form. So let me write this. We have 2x to the 4th power, then plus our 10x cubed. We're missing x squared, so I'm going to put plus 0x squared, then minus 32x, and then minus 22. So now this polynomial is in standard form. So let me move this over here. Let me do this like this. And then I have 4 plus 2x. I'm going to switch that around to 2x plus 4. And now we're basically good to go. So let me grab this and let's go ahead and get started. So we want to go leading term into leading term. So 2x to the 4th power divided by 2x. 2 divided by 2 is 1. X to the 4th power divided by x is x cubed. So let's put this as x cubed like this. Then x cubed times 2x is going to be 2x to the 4th power. And then x cubed times 4 would be plus 4x cubed. Okay, we're going to change the sign. So this is minus and this is minus. We'll go ahead and say 2x to the 4th power minus 2x to the 4th power is 0. 10x cubed minus 4x cubed is going to be 6x cubed. Drop this guy down. So you could put plus 0x squared like this. And then I'm going to erase this. And I'll go ahead and highlight this. So leading term into leading term. 6 divided by 2 is going to give us 3. So let's put, and then you change this back. So plus 3. And then x cubed over x is going to be x squared. So multiply 3x squared times 2x. That's going to give you your 6x cubed back. And then 3x squared times 4 would be plus, you would have 12x squared. Okay, let's do this. This is going to be minus. This is going to be minus, just changing the signs. Obviously, 6x cubed minus 6x cubed is 0. And then this guy here, so this would be negative 12x squared. Drop this guy down, so minus 32x now. Again, let me erase this highlighting. We're going to go this leading term into leading term. So we have negative 12 divided by 2. That's going to give me negative 6. Let me put minus 6 here. X squared over x is just going to be x. Okay, so I'm going to start to run off the screen here. So negative 6x times 2x plus 4. So let me write this down here. Negative 6x times the quantity 2x plus 4. So let's do negative 6x times 2x. That's going to give me negative 12x squared. And then negative 6x times 4, well, that's going to be negative. 6 times 4 is 24, and then x comes along for the ride. So let's get rid of this. And then I'm going to change this to plus and this to plus. So negative 12x squared plus 12x squared is 0. Negative 32x plus 24x is going to be negative 8x. And then let me drag this up here so we can see. we're going to be dropping this negative 22. Okay, so bring that down. So we have negative 22 here. Let me go ahead and erase this, and I'll highlight this. So then you're going to have negative 8x divided by this 2x here. Negative 8 divided by 2 is negative 4. X over x is 1. So this is going to be minus 4 here. Okay, let's go ahead and multiply negative 4 times 2x plus 4, that quantity. So negative 4 times the quantity 2x plus 4. Negative 4 times 2x is going to be negative 8x. Negative 4 times 4 would be minus 16. Okay, so let's get rid of this. Change our sign, so this is plus and this is plus. And so what we'll have here, negative 8x plus 8x is 0. Negative 22 plus 16 is going to be negative 6. There's nothing else to bring down, so this is going to be my remainder. Okay, so let's paste this in here. And I'll put plus, remember we have our negative 6 for the remainder, over 2x plus 4. Now, you can further simplify this part right here, because what's going to happen is, let's write this over here. We haven't really gotten into rational expressions yet, but you have negative 6 over this 2x plus 4. I can factor the 2 out. We talked about this earlier in the course. So we would have a common factor of 2. So we could pull that out and we'd have x plus 2 inside. So 2 is multiplying the quantity x plus 2. So what I can do is write this as, let's say, negative 1 times 3 times 2 to make this crystal clear. I can cancel this factor of 2 with this factor of 2. And what I'll be left with is negative 3. So let's write this as negative 3 over my x plus 2. So over my x plus 2. So that would be our final answer. Of course, you can put this as minus and put a 3 up there. It's really up to you. So you'd have x cubed plus 3x squared minus 6x minus 4. And then minus, you have this 3 over x plus 2. All right, let's take a look at problem number 9. So we have 6x to the 4th power plus 3x cubed minus 17x squared minus 7x plus 7. So it's in standard form, not missing any powers. Then this is over 3x squared minus 7. So this guy is missing x to the 1st power. So we need to write that in. So let's put our 3x squared plus 0x and then minus 7. And then over here, let's do our 6x to the 4th power, then plus our 3x cubed, then minus our 17x squared minus 7x, and then plus 7. So again, leading term into leading term. I think at this point you probably get it. We don't need to highlight things, but just for clarity, leading term into leading term. So we would say 6 divided by 3 is 2. X to the 4th power divided by x squared is x squared. So this would be 2x squared. Let me write that right there. And let me probably change colors here so that it stands out more. So let's put 2x squared like this. And let's multiply. 2x squared times 3x squared will give me the 6x to the 4th power back. And then 2x squared times 0x, I'm going to put is plus 0x cubed. And then 2x squared times negative 7, I'm going to put as negative 14x squared. So let's put this down here. Let's go minus, minus, and then this will be a plus. So just change the sign of everything. So obviously 6x to the 4th power minus 6x to the 4th power is 0. 3x cubed minus 0x cubed would be 3x cubed. And then negative 17x squared plus 14x squared would be negative 3x squared. Okay, I'm going to drop this guy down here. Let me change my color up just so we can keep this separate. Now I'm going to erase this and I'm going to highlight this. So leading term into leading term, 3 over 3 is 1. X cubed divided by x squared is just x. So I'm going to put plus x and then multiply x times 3x squared will give you the 3x cubed back. Then x times 0x, I'm going to put plus 0x squared. Let me erase this and put it better. So 0x squared. And then x times negative 7 is minus 7x. So let's go through here. Let's write this as a negative. Let's write this as a negative. And let's write this as a plus. So 3x cubed minus 3x cubed is 0. That's gone. Negative 3x squared minus 0x squared is just negative 3x squared. Then we have negative 7x plus 7x. So this is canceled. You might want to write, just for clarity, plus 0x for right now. And then you can drop down this 7. This right here is unnecessary. It's just up to you if you want to do that, again, for clarity. So let me go ahead and highlight. I'm going to get rid of this and highlight this. And then we're going to do leading term into leading term. So negative 3 divided by 3 would be negative 1. So let's put negative 1. X squared over x squared, that's going to cancel and become 1. So the answer there would be negative 1. And of course, we multiply. Negative 1 times 3x squared would be negative 3x squared. Negative 1 times 0x, let's put that as, we'll put minus, we'll put 0 x, that would be fine. And then negative 1 times negative 7 is going to be plus 7. Okay, so we're going to change the sign of everything. So this is going to be plus, this is going to be plus, and this is going to be minus. And so in this case, we actually don't have a remainder. Let me see if I can keep this all on the screen. Let me scroll up just a little bit. So this guy right here, negative 3x squared plus 3x squared, that's gone. 0x plus 0x, that's gone. Forget about that. That's just 0 plus 0. And then 7 minus 7 is 0. So this is my remainder here, which is 0, which means I don't have a remainder, right? There is no remainder if it's 0. So I could just write that, 2x squared plus x minus 1. So that's my answer. All right, let's look at problem number 10. So we have x to the fourth power minus 2x squared minus x minus 1 over x squared minus 5. Okay, so I am missing x cubed here. So let me write x to the fourth power plus 0x cubed, and then minus 2x squared minus x minus 1. So we're good to go. Again, make sure you put that 0 in because you're missing x cubed. Then we're going to set this up. Over here, I'm missing x to the first power. So I'm going to go x squared plus 0x minus 5. Okay, so we've got everything set up. So again, leading term into leading term. So what is x to the fourth power divided by x squared? Well, that's going to be x squared. Then x squared times x squared is x to the fourth power. X squared times 0x would be 0x cubed. And then x squared times negative 5 would be minus 5x squared. Let's change the sign of everything. So plus, minus, and minus. And this is basically going to cancel. X to the fourth power minus x to the fourth power, that's gone. 0x cubed minus 0x cubed, that's gone. Negative 2x squared plus 5x squared would be 3x squared. Let's drop down this minus x here. And again, let me go ahead and get rid of that. And I'm going to highlight this guy. So leading term into leading term. So what is 3x squared divided by x squared? Well, that's just going to be 3. So plus 3. Then multiply 3 times x squared is 3x squared. And then you're going to have 3 times 0x. You can just put plus 0x if you want. And then 3 times negative 5 is minus 15. Okay? So let's go ahead and go over here. Now, for clarity, because you don't have anything to combine with that, some people get confused. You can just put plus 0 if you want. Okay, you can always add 0. It's just like us putting 0 here as a placeholder in front of the x. Really the same thing if it gives you trouble. So you put a negative here, and a plus here. And let's go ahead and combine like terms. 3x squared minus 3x squared is 0. Negative x minus 0x. So again, this is like 0 here. So you basically just have the negative x. Then 0 plus 15, you just have the plus 15. Okay, let's drop down this minus 1 here. And again, this is a little bit confusing for people. A lot of people get stuck here. But all you're doing here is just combining like terms. If I have 15 and I bring down a minus 1, well, 15 minus 1, if I have this polynomial, I can just say 15 minus 1 is 14, right? So at this point, I could really just erase this and put 14. I know that gives students a lot of trouble when they solve this problem. That's all you really need to do there is just combine like terms. Okay, so let's get rid of this, and let's go ahead and get this. So I'm going to go leading term into leading term. So what is negative x divided by x squared? Well, we're actually going to need to stop at this point because you stop your division when the degree of this guy right here is less than the degree of this guy right here. So in other words, the degree of this polynomial here is 1. The degree of this polynomial here is 2. So you're going to stop and say that this is actually your remainder. Okay, so your answer here would be x squared plus 3. So x squared plus 3. And then your remainder, you could put plus. You'd have negative x plus 14 over this x squared minus 5. So let me copy this, or actually cut it. We'll come back up and we'll paste this in and put this in here like this. And again, if you wanted to check this, you could, right? So you'd multiply this times this, okay? And then when you're done, you just add this negative x plus 14, and you'd basically be back to this. And we can do that real quick just for clarity. If you don't care, then you could just exit the video. But let's go ahead and do that real quick just to prove to you that this works. So I'm going to do x squared plus 3, this quantity, times x squared minus 5, this quantity. When I'm done, I'm going to add that remainder of negative x plus 14. Okay, so x squared times x squared is x to the fourth power. And then the outer would be minus 5x squared. The inner would be plus 3x squared. Combined like terms, you have negative 2x squared, so minus 2x squared. And then for the last, 3 times negative 5 is negative 15. Okay, so I have this part right here, and it doesn't quite match what I have up there. But again, if I add the remainder, so plus, we have negative x, and then plus 14. So negative 15 plus 14 is going to give me negative 1. So let me go ahead and put -1 here, and I'll just slide this down. And you can just change the notation, okay, to minus there, and maybe write a little bit further out like this. And you can see that we're back to this. So x to the 4th power minus 2x squared minus x minus 1. All right, let's take a look at our practice test. So we want to find each quotient. And for the first problem, we're going to be looking at x cubed plus 9x squared plus 26x plus 30. And this is over, you could say divided by x plus 5. Now, of course, we could use the polynomial long division process that we've already mastered, but we want to use the little shortcut here because it qualifies for it, known as synthetic division. So synthetic division is going to be very important for us in algebra when we get to finding the zeros of polynomial functions, but that's not for a while in the course. It's just a good idea to get this skill under your belt early. So the way I would think about this is I can use this shortcut if my denominator or my divisor here is a binomial, so a two-term polynomial of the form, we want x minus k. Now this x here, notice that it has a coefficient or an implied coefficient of 1, and that it's raised to the first power, right? So if I look at just x by itself, the implied coefficient is 1, the implied exponent is 1. Okay, then this minus some number here, okay, whatever it's going to be. If you have plus 5 like you have here, you can change that to minus a -5. Okay, if you have minus something like 3 or something like that, then that's just fine. So let's go ahead and erase this. And let me show you how to set this up. Essentially, you want to make sure that when you're looking at your numerator or your dividend, that this guy is in standard form. And you need to make sure you're not missing any powers, okay? If you're missing powers, again, use that trick where you're using 0 as the coefficient for that missing power, okay? But we'll get to some examples of that later on. For right now, this guy is good to go. It's in standard form, not missing anything. So what you want to do is actually just grab the coefficients. So I'm going to put this as a visible coefficient of 1 because that's implied. And then I'm going to grab these guys. Again, because it's in standard form, it'll be in the correct order. So 1, then 9, then 26, then 30. So I want 1, then 9, then 26, and then 30. Okay, let me make this little symbol here. And then what do I want over here to the left? This part right here is where you really need to pay attention because it's where everyone messes up who has trouble with synthetic division. You have a form that's given to you in the book of x minus k. So if it doesn't match this form in terms of the sign like it doesn't here, you need to take an additional step and you have to rewrite this guy, okay? So what I'm going to do is rewrite this as x minus a -5. Remember, minus a negative is plus a positive. So what I want to do is just grab whatever k is. So whatever is to the right of that minus sign. In this case, what's to the right of the minus sign? It's -5. So I always want to grab whatever is k, and I want to put that over here in this position. So I'm going to put my -5 here. Again, the common mistake is just to not do this extra step, to grab the 5, put that out there, and that's going to give you the wrong answer, okay? So let's get rid of this. I'm going to copy this. Now the process, once you've set everything up, is quite simple. I'm going to put a horizontal bar down here, and I probably should make that a little bit straighter, or at least attempt to. And then I'm just going to drop the first number down. So I'm going to put that right there. And then all I'm going to do is go through and do a multiplication, then addition. Multiplication, then addition. I'm just going to repeat that process until I get to the end. It's really quite simple. So you're going to start with -5 times 1, and that's -5. So I'm going to put my answer right there. And then I'm just going to add. So 9 plus -5 or 9 minus 5, however you want to do that, is going to be 4. Then you're going to do -5 times 4. That's -20. 26 minus 20 is 6. -5 times 6 is going to be -30. 30 minus 30 is 0. Now, these numbers down here in our what I'd call answer row represent coefficients for the quotient, okay? So how do we interpret this? Well, let's go back up for a moment and get a little insight. If I was to set this up as a long division, so let's go x cubed plus 9x squared plus 26x plus 30. And let's say I'm dividing this by, we have this x plus 5. Well, we know that the coefficient of this guy has to be a 1, right, to qualify for synthetic division. And also we know that my exponent here is a 1. Well, let's think about this. When I first start my division, I go leading term into leading term, right? We know this is listed in standard form. So my highest exponent is always going to be all the way to the left. And whatever that is, let's say it's x cubed in this case, when I divide it by x to the first power, whatever the coefficient is here is still going to be there. Okay, in this case, it's 1, but let's say it was 9. Well, 9 divided by this is 1. You're still going to have 9, okay, whatever it is. Then you have this exponent of 3. Well, x cubed divided by x, remember this exponent's always going to be 1. It's just going to be subtracting 1 away from whatever this is. So you would have x squared. If this happened to be x to the 5th power, you'd have x to the 4th power, so on and so forth. So the first number that we get is going to be the coefficient for the x that's raised to the power that's 1 less than whatever this guy was. So if your degree is 3 like it is here, now your degree is going to be 2. Okay, so you're going to have x squared. So if I go back, this 1 right here is the coefficient for x squared. You could write 1x squared or just x squared. It's all the same. Then you just keep going down. So then you'd have plus 4x, then plus 6. And this last spot right here is going to be your remainder. Okay, in this case, it's 0, so there is no remainder. So our answer here, let me just cut this away. So I'll put equals and just paste this in and put that right there. Our answer is x squared. And then plus 4x plus 6. Again, you can always multiply this by this and get this back if you want to check it that way. You could also pause the video and do a polynomial long division. You see that you get the same answer. Okay, let's look at problem number 2, and we'll just pick up the pace a little bit. So we have x cubed plus 15x squared plus 60x plus 28 over x plus 7. So again, I want to write this as x minus a negative 7. Don't forget that step. And then in my dividend or my numerator, I'm not missing any powers. Everything's in standard form. So I'm just going to take the coefficients. So 1, 15, 60, and then I have 28. And then let me do this right here. I want to do this number right here. Again, what's to the right of the subtraction? It's negative 7. And then you can just drop this down here, and then you can start. So negative 7 times 1 is negative 7. And then 15 minus 7 is going to be 8. Negative 7 times 8 is negative 56. 60 plus negative 56, or 60 minus 56, is 4. Negative 7 times 4 is negative 28. 28 minus 28 is going to be 0. So again, this coefficient right here starts things off. If this guy was x cubed, well, now I'm going to have x squared. So in my answer, and you can just erase this. You don't really need it anymore. You just need these numbers. The answer, let me put equals, and let me get rid of this, is just going to be x squared. And then I'm going to have plus 8x, and then plus 4. And that 0 there would be your remainder, which means you don't have a remainder. So my answer here is x squared plus 8x plus 4. Okay, let's look at the third problem. So we have 7x cubed plus 51x squared plus 50x minus 24 over x plus 6. Again, I'm going to write this as x minus a negative 6. And again, this is in standard form. I'm not missing anything. So I'm just going to grab my coefficients. So I'm going to grab a 7. I'm going to grab the 51, the 50, and the negative 24. Okay, so that's all I'm doing. And then over here, I'm grabbing the negative 6. I'm going to drop this down. So drop this down. Negative 6 times 7 is negative 42. 51 minus 42 is going to be 9. Negative 6 times 9 is going to be negative 54. 50 plus negative 54 would be negative 4. Negative 6 times negative 4 is 24. And then negative 24 plus 24 is 0. Okay, so no remainder. And again, if this exponent here is a 3, then this guy is going to be x squared, right? So this is going to be 7x squared. Let me just erase all this. I'll put equals, and we'll have 7x squared, and then plus our 9x, and then minus 4. And of course, the remainder here is 0. So that's your answer, 7x squared plus 9x minus 4. Okay, let's look at problem number 4. So we have 3x cubed plus 2x squared minus 29x minus 24 over x plus 3. So again, I'm not missing anything, and everything's in standard form. I need to make sure I write this as x minus a negative 3. So I'll have 3, I'll have 2, negative 29, and negative 24. Okay, so I'm just taking these coefficients, and let me put this over here. I want negative 3 over here. Let me put my little horizontal bar, drop this guy down. Negative 3 times 3 is negative 9. 2 plus negative 9 is negative 7. Negative 3 times negative 7 is positive 21. Negative 29 plus 21 is going to be negative 8. And then negative 3 times negative 8 is 24. Add negative 24 and 24, you get 0. Again, if this polynomial has a degree of 3, this guy's going to have a degree of 2. So that means you're going to have x squared there to start things off. And just say this is x squared, so 3x squared minus 7x minus 8, and then the 0 is a remainder. So 3x squared minus 7x minus 8. Okay, let's look at problem number 5. So we have x to the 4th power minus 6x cubed plus 4x squared minus x plus 25 over x minus 5. So let me put equals here. This is already in the form of x minus k. So in this case, you don't have to do anything. You just grab the 5, okay? So let me put this over here. I'm going to have, again, this is an implied coefficient of 1. this is negative 6, this is going to be 4, this is negative 1, and this is 25. So again, you're not missing anything in your numerator, and this is already in standard form for us. We have 4, 3, 2, 1, and then our constant over here. So everything's good to go. And let me make these signs a little bit better. Let me put that down, squinch it up a little bit. And then again, I can just take this 5. Because this is of the form x minus k, I can just take whatever k is. So I can just take the 5. I don't need to do any adjustments there. So go ahead and drop this down. 5 times 1 is 5. Negative 6 plus 5 is negative 1. 5 times negative 1 is negative 5. 4 plus negative 5 is negative 1. 5 times negative 1 is negative 5. Negative 1 plus negative 5 is going to be negative 6. And then 5 times negative 6 is negative 30. So 25 minus 30 would be negative 5. So this right here is your remainder. Okay, let me get rid of all this. And again, the degree here is 4, right? This exponent here is a 4. So this 1 here belongs to x cubed, right? That's the coefficient for it. So we would say we have x cubed, and then we'll put minus x squared, and then we'll put minus x, and then we'll put minus 6. And then again, this minus 5 here, this is the remainder. So you can put plus negative 5. You can put plus, again, negative 5 over x minus 5. Or you could change this to minus and make this positive. Again, whatever you want to do. It's the same answer either way, just different ways to write it. So you have x cubed minus x squared minus x minus 6 minus 5 over x minus 5. All right, let's look at problem number 6. So we have x to the 4th power plus 2x cubed minus 17x squared plus 11x minus 12. This is over x minus 3. So again, this is all in standard form up here, not missing anything. So I'm just going to take my coefficients. So 1, 2, negative 17. I want 11 and then negative 12. And then over here, again, because this is of the form x minus something, I can just take this. So I can just take the 3. Don't need to make any adjustments there. Let me scroll down so I can fit this on the screen. So I'm just going to drop this down. 3 times 1 would be 3. 2 plus 3 is 5. 3 times 5 is 15. Negative 17 plus 15 is negative 2. 3 times negative 2 is negative 6. 11 plus negative 6 is 5. 3 times 5 is 15. And then negative 12 plus 15 is, of course, 3. So again, this guy in the last position is your remainder. Okay, so keep that in mind. Let me actually erase this so I can fit everything on the screen. So again, when we think about interpreting the answer, this exponent here is a 4, right? So the polynomial is of degree 4. So this polynomial will be of degree 3. So in other words, this 1, this first coefficient here, is going to be for x cubed. So this should be 1x cubed or just x cubed. Then plus, you just keep going down. So then you'd have 5x squared. And then you'd have minus 2x. Then you'd have plus 5. And then your remainder is 3. So plus, I'm going to go 3 over. You have this x minus 3 here. Let me get rid of this. So the answer is x cubed plus 5x squared minus 2x plus 5 plus 3 over x minus 3. All right, let's look at problem number 7. So we have 4x to the 4th power minus 3x cubed minus 18x squared plus 20x minus 6. And this is over x minus 2. So let's scroll down a little bit. See if we can fit everything. Again, I'm in standard form up here, and I'm not missing anything. So let's go ahead and put this like this. So we have 4, we have negative 3, we have negative 18, we have 20, and we have negative 6. Let's continue that over there. Again, this is of the form x minus k. I don't need to make any adjustments because this is a minus, so I can just take the 2 there. And let me just copy this. I think there's probably not going to be enough room here. And let me paste this in. And of course, I'll make this little horizontal bar. Let me drop this guy down. So 2 times 4 is 8. Negative 3 plus 8 is 5. 2 times 5 is 10. Negative 18 plus 10 is negative 8. And then 2 times negative 8 is going to be negative 16. 20 minus 16 is 4. 2 times 4 is 8. Negative 6 plus 8 is going to be 2. All right, let me paste this in here like this. And again, if this guy right here is a 4, right, if the degree is 4 of this polynomial, the degree of this polynomial will be 3. So this would be 4x cubed. And then this is all over the place. So let me kind of scooch this down. I'll put plus, this will be 5x squared, and then minus your 8x, and then plus 4. And 2 is the remainder, so I'm going to put plus. I'm going to put plus 2 over your x minus 2. Okay, so let me put equals there. So the answer is 4x cubed plus 5x squared minus 8x plus 4 plus 2 over x minus 2. All right, let's look at problem number 8. So we have x to the 4th power minus x cubed minus 26x squared plus 23x plus 27, and this is over x minus 5. So again, everything's in standard form. Nothing is missing here. Just going to take my coefficients. So I have a 1, I have a -1, a -26, I have a 23, and a 27. Bring this over here. Again, this is x minus 5, so I could just take the 5. And let's see, do we have enough room? I think we maybe do. Let's drop this down. And let's go through. So 5 times 1 is 5. -1 plus 5 is 4. 5 times 4 is 20. -26 plus 20 is going to be -6. 5 times -6 is -30. 23 plus -30 is going to be -7. 5 times -7 is -35. And then 27 minus 35 is -8. So again, this right here is your remainder. Let me put equals here. And so again, this is a 4 here, right? So the degree of this polynomial is 4. This guy would be 3. So this would be x cubed plus, you go 4x squared minus 6x minus 7. And then you can go minus, you can go plus, negative, whatever you want to do. I'm just going to go minus. I'll put the 8 over the divisor, which is x minus 5. Let's get rid of this. So this will be our answer. I'll just drag it up so it's a little bit more neat. So x cubed plus 4x squared minus 6x minus 7. And then minus, you have 8 over x minus 5. Let's look at problem number 9. So we have x to the 4th power plus 9x cubed plus 15x squared minus 5x minus 9. This is over x plus 2. So again, change this to x minus a -2. And let's scroll down a little bit and have a little room for us. So again, everything's in order. Nothing's missing. We'll see that things will be a little bit different in the next problem, the final problem. But I'm just going to grab my coefficients. So 1, 9, we'll have 15, we'll have -5, and then -9. And then over here, I'm going to grab my -2. Remember, I changed the form because this is plus. So I'm going to grab my -2. I'm going to drop this down. Let me scroll down so we have enough room to work. Let me put this over here. So -2 times 1 is -2. 9 minus 2 is 7. -2 times 7 is -14. 15 minus 14 is 1. -2 times 1 is -2. -5 plus -2 is going to be -7. And then -2 times -7 is going to be positive 14. -9 plus 14, you can think about that as 14 minus 9. That is going to be positive 5. Okay, so this is going to be your remainder. Let me highlight that. Let me put equals. And so again, this guy is of degree 4, so this guy will be of degree 3. So this would be x cubed plus 7x squared plus x minus 7, then plus your remainder is 5, so 5 over your divisor, which is x plus 2. Let's get rid of this, and let's drag this up a little bit. It's a little bit cleaner. So again, the answer is x cubed plus 7x squared plus x minus 7 plus 5 over x plus 2. All right, so problem number 10, I threw a few little curveballs at you. So we have 4x cubed minus 2x plus x to the 4th power minus 15 over x plus 4. So the first thing is it's not in standard form. Let me come down here a little bit. And let's go ahead and say this is x to the 4th power and then plus 4x cubed. Notice that I'm missing x squared. So again, I want to rectify that by putting plus 0x squared. Make sure you do this, okay? Then let me change this back to the other color. We'll have plus, I have actually negative, so minus 2x, so minus 2x, and then minus 15. Okay, so this is just the updated version of this, putting it in standard form and accounting for this. That's all I did. Then this is over. Let me put equals here. This is over. X plus 4, I'm going to change that to x minus a -4. And let's come down now. Get ourselves some room. We're ready to actually set this up. And so I'm going to take the coefficient of this guy. So 1, then 4, then put the 0 in, then -2, then -15. Okay. Let me put this here. Let me make this symbol. And again, I'm grabbing the -4. I made that change. So I'm putting -4 here. Go ahead and drop this down. Let me scroll down a little bit more. See if I can get everything on the screen. So drop that down. Let's go ahead and multiply. -4 times 1 is -4. 4 plus -4 is going to be 0. Then -4 times 0 is 0. 0 plus 0 is 0. -4 times 0 is 0. -2 plus 0 is -2. -4 times -2 is positive 8. -15 plus 8 is going to be -7. So again, this is the remainder here. Okay, this is the remainder here. And now how do I interpret when I have a 0 here? Well, it's like having 0 for the coefficient of whatever that term is, right? These are placeholders for us. Let me erase this. I'm going to show you that that's going to make a whole lot of sense. Let me erase all this. Okay, so I erased the standard form that we had, but we remember that the highest exponent is a 4. And so the degree of this guy was 4, so the degree of this guy will be 3. So let's take this 1, that's the coefficient of x cubed. Then the 0 is the coefficient for x squared. The next 0 is the coefficient for x. Then you have minus 2, and then you have minus your 7 over your x plus 4, because again, this is the remainder. Now, do you need the 0x squared and the 0x? You can drop them now that you've set up your answer. Again, those are just placeholders for you so that you don't mess things up. So you can get rid of this, and you can collapse this answer down. So you can collapse this down and say that this is x cubed minus 2, then minus your 7 over your x plus